Yeah. Okay. Yeah. Thank you. The students who are
Hello.
hello. Yeah. Okay. Thank you. Sorry for the inconvenience. The metal organic framework. So this is something which not a new material or anything, which was there already before. So what do you mean by this metal organic framework? There should be a metal and there is an organic linker which will give you a framework. And they are actually a two-dimensional and a three-dimensional structures are possible from this. And they are the versatile class of coordination polymers which mainly consist of this metal and this organic linkers. When you look at the applications of this metal organic framework, you can have a high porosity. This is one of the major aspects of this MOF material. They have a high surface area and a tunable structure. While few of them shows a very high conductivity and they have the fuel storage capacity mainly for the carbon dioxide or hydrogen or anything. And it is now acting as a biocatalyst for a biological teachers, and there is something called a biosensing properties are also showing. So because of these versatile properties of the metal organic framework, it came into the scientist area. And if you remember, the last year Nobel Prize winners were given by the metal organic framework in this Omar Miyagi. He was known as the father of metal organic framework, and his team from Suzuma Kitagi and Richard Robson, they three of them won the Nobel Prize in Chemistry in 2025. So that shows the importance of metal organic framework. And the traditional design principle, when you look at for this metal organic framework, how it is coming, they are actually around the metal and the organic linkers, which I told you. So there are metal nodes and the organic linkers are there, and then how they are connecting with each other. That is what gives you the properties. And it will create the framework which specific structures and the properties and the functionalities. Since we can include the functionalities in this molecule, that is why the importance. So what is the application that you are looking? Accordingly, you can include the functionalities in this MOF structure. So the key principle is primarily involving the careful matching of these metal salts and the ligands and the solvent and the reaction condition. The reaction condition will give you whether the MOF will form as a crystal or as a powder, or whether you are getting or not. Sometimes the students need to keep it for n number of reactions, n number of combinations for the optimization. You can try with the different solvents, you can try with a mixture of solvents, which one is giving you the best results. But once you decide that one, this is the optimized condition, it is very, very easy for you to synthesize this material for that. These are the two important MOFs which our students from our lab that we have synthesized, which is a tin-based MOF, potassium and tin, two metals has been added into that one, and another one is a potassium tin, same MOF, same material, but you can see how the structure is different depending upon the conditions and all. So this work we have patented, and we are working on the application of these two particular MOF. And depending upon which metal that you are starting and which solvent you are using and which is the organic linker, you can see the crystal structure itself. It is giving you different types of structures that it is coming for you. And the properties and the application, when I looked at it, it can be used in catalytic activities. So it is a very good catalyst. It has the capacity of an adsorption, so you will be able to use it for the water treatment, and it has an increased surface area which will help you for the catalytic activities actually. And the physical and the thermal stability is there. It is much stable even if at a higher temperature when you are going for that. And crystallinity, and it is a flexible structures are coming, and you can have the electrochemical character because it can pass the electrons into that one, so that gives you the application in the energy storage, and there is methane storage can happen, and you can have the viable organic functionality that you can do it for this one, so that will give you for the biosensing application. And people are working mainly on this catalysis, the water treatment, carbon dioxide capture, because carbon dioxide is one of the major pollutant now people are working on how to convert this carbon dioxide into a useful material which can be used for any of the other application. And based on this, we have worked on one particular MOF which are showing actually two different properties, which is a nickel PTC MOF, and this showing a two different properties, like it can act as a very good supercapacitor and it can be used for a water splitting application. Water splitting is nothing but the normal water. If you split it into the, we know the simple school chemistry, it can give rise to the hydrogen and the oxygen. The importance of hydrogen generation is nothing but it can be now a green hydrogen, because there is no pollutant that is coming. So how can we change our fusel fuel and go into a green way or a green hydrogen or any of the green method that people are working on? So we found that this particular MOF can also be used as a water splitting catalyst, and we will be getting the hydrogen generation. But we did it in the way of actually the electrochemical method. So maybe we need to work on how can it be gone into a industry level, because the amount of hydrogen that is needed is much higher compared to a lab scale. But these materials, MOF materials, are ready to be used as a water splitting catalyst also. So maybe we have to work on a little more higher level in order to get this particular application. And the next one, the current trend, what is challenges and the opportunities, or what industry people are looking on that one. One is the scalability and the cost issues. There is one of the major challenge, because I told you the optimization itself will take time. It is not like a simple one, you mix it and you are getting, because you need to work on the different solvents and which is the best condition that it is coming. It may take a little time for that one. And after that, the post-synthetic modification also limitations are there. Whatever the modifications you wanted, actually you need to do during the synthesis time itself. After the post-synthesis and then you are doing for a functionalization, we are not getting the actual result what we wanted in that one. So again, the optimization, again you have to do it here. And reproducibility and a batch-to-batch variation it is coming. Unless you hadn't kept the correct timing or correct temperature, whatever it is required, again to synthesize reproducibility. If you are not giving the exact one, it becomes a difficult. You will be getting another type of MOF coming. So the student point of view, you need to write each and everything what you are done for the synthesis of one particular material. Exactly the same thing you need to do it for getting the next batch of material. But there are n number of opportunities are there with respect to the MOF material. Mainly the energy storage and the energy conversion is what people are looking into that one. Another area is the biological area, where the sensing applications are also going on. So there are n number of opportunities are there, and how to commercialize, scale up the production and commercialization is another area where the industry people or those who are interested in this MOF synthesis, and you need to find out or how will be the cost effectiveness that is happening, and how can we go into the industry level or the industrialization or industry people. You can connect it with them and then see how this material can be done. And now slowly people are doing with the AIML assisted process also, so that the number of optimization conditions, maybe you can reduce it if an AI can give you some of the input, so that only if those inputs you can do it in the experimental condition. So another material which I would like to introduce is something known as MAXenes. Maybe a few of the people will know. It is a two-dimensional material. It has the graphene-like structure, so that is why the name of MAXene is coming. It is similar to the graphene-like structure, and generally it is having a formula of metal. M represents them MXT, where M is the metal. Generally the transition metals that we are using, the first series of transition or the second series of transition metals, you can use it. And X can be either carbon or a nitrogen, while this T represents the terminating group, which we call it as oxygen, fluorine, OH or chloride ions that people are using. You can see that it is a layered structure that is coming. There are different ways that you can synthesize. It is an etching is the most important process where people are working on, and it is giving you a very good results. And all these MAXenes are synthesized from something known as max phase. The corresponding max phase you should synthesize. From their etching process or top down or a bottom up approach you have to do. When you look at the properties, it also has the electrical and thermal conductivities and the optical properties, and has a mechanical strength. And mainly energy, catalysis and sensing are the areas where now the MAXenes were used, but there are n number of options are available. when you look at the Maxine's history, it is actually a baby in the history of our 2D materials when it is coming, because it started only in the year of 2011. So compared to graphene, it is a long journey. So maybe we will expect one or the other Nobel Prize is coming to the Maxine also. So Yuri Gagarin is the father of Maxines, we can tell that. He was the one who discovered this importance of Maxine, and this is one of his book, very nice to read. All the properties, all the synthetic strategies, everything has been written in this particular book, Yuri Gagarin. So maybe we are expecting many work has been expanded in this particular area. And properties and applications, when you look at in this, it is a hydrophilicity is one of the important properties, and you can tune the surface. I had shown you the surface to emanating groups which can easily form on the surface. It has a high Young modulus and a thermal conductivity, good in electrical conductivity. Because of that properties, you can use it for the supercapacitors application. And there are few Maxines where the band gap can be tuned, especially titanium based material, so that the photocatalysis it can be useful. And it is a metallic in nature, and it has a large surface area that it is coming for that. So the important areas where the work is already done, some of the areas work is going on: energy material, catalysis, optical properties, electronics properties. Synthesis processes are one area where people are working, and since because it has a high Young modulus, mechanical properties are also there, and environmental applications are also working on. But environmental application, as I mentioned, mainly if you are able to change the band gap of the material. And titanium is a material where you know that it is easy to come under the solar light band gap energy. So it is working on that particular area. One of the important studies which started with the Maxine is based on the titanium carbide. This is a Ti3C2 structure, and it has a properties which I mentioned in the previous slide. Synthesis process, if you are looking, it is main thing is happening by means of from max phase by HF etching, or an alkali etching, or a molten salt etching, or the acid fluoride etching. Many different ways that we can do. We also tried in all the different ways, and the best activity or best easy way of coming is actually by the HF etching that is going on. But I know that HF is a little carcinogenic, and the usage of HF in the lab is limited. So to take it into the higher level or the next level is becoming a little difficult, but we are working on the other areas, maybe an alkali etching process. You are getting the result. Only thing is that the aluminum is not etching completely. So in the max phase, if you look at the structure, this is what the max phase we call it as. This A is like an aluminum layer. So generally A will be an aluminum layer that is coming. You need to remove this aluminum layer in order to get your Maxine. It is a layered structure. You can see the structure. It is just like our graphene structure. It is having a layered structure. But what happened, depending upon your etching process or an etching agent, this aluminum layer is not completely etched out. If the aluminum layer is there, your properties will change. So conversion of max phase to Maxine, little importance, because you have to remove as much as possible the aluminum layers from that one. So when you look at the structure property correlations, when you are looking, transition metal compositions is electronic and catalytic properties we can do, because most of this material contains a transition metal, which we know that the D block elements, and you have the free electrons are there, and that is easy to move around, so we can use it for any of the electronic application that is coming. And different M metals tune the metallicity and the magnetism and the catalytic behavior. You can do even a doping process, which generally for catalysis people are doing. Any of the dopant you can add into the material, and you can have something called the structure functionalization. The surface is easy to functionalize. Mainly it can have the fluoride, chloride, OH groups can be attached very easily, and those functionalized groups will help you for the further reactions to occur that one. And the composites are generally now prepared. Maxine with a morph is one of the composite that our students are actually working on, because to include both the properties of these materials. And X element is actually a carbon and the nitrogen. So the mechanical and the structural stability of these materials are also very important coming. And the carbon and the nitrogen ratio is also very important. So depending upon this ratio, it will improve the rigidity and the thermal stability. So you can add actually how much that you wanted or how it is going on. Depending upon that, you can change the properties also. Just to give you an input on the current research on the maxims and what are the opportunities for the students who can work on that one. It has a very high electrical conductivity and the mechanical flexibility and the multi-functionalities which you can include in the surface of that, and it is rich in surface chemistry. So use these properties and you look at the application or you look at the area where these type of properties can be included. Those areas you can go for these maxims. And only thing is that Maxine's stability is an area where challenging, and the surface groups where you should control, because it is very easy to functionalize the material. So we need to control how much functionalities are required for that one. And it is easy to hybridize with the other materials are also. And scalability is a one issue which I told you that it is something which we need to have the HF etching, and if the aluminum is not removed it completely, then it becomes a little difficult task. So we need to optimize the conditions, and then slowly only we can scale up. A large quantity synthesis is becoming a little difficult for that. So based on this, we also done one of the, our group was doing many max phase conditions and maxines. So max phase and maxines we have synthesized for chromium metal. And
sorry madam, just 5 minutes is left.
yeah,
Oh,
last
thank
slide,
you.
sir. Oh, yeah. Okay. So for using this supercapacitors and the electrocatalytic water splitting studies were also done using this material. Max phase is also working and maxines are also working for this particular application. So few of the references which is working on this type of MOF and the maxines materials, and sorry, thank you for your thing. Any queries or anything? It is not a full work we haven't prepared, but I had given you an input on the area where students can work actually.
Contribution to magnetic resonance, quantum information processing and quantum technologies. His innovative research has significantly advanced nuclear magnetic resonance methodologies and their applications in quantum computing and quantum stimulations. Following doctoral study at the Indian Institute of Science and postdoctoral at MIT USA and the University of Dortmund, Germany, he has established an internationally recognized research program at IISER Pune. A recipient of Humboldt Fellowship, MIT Cambridge Fellowship, DST Swarna Jayanti Fellowship, and Professor S. Subramanian Lecture Award, he has made outstanding contribution to physics, research and scientific leadership. Welcome, sir. Stage is inviting you.
Okay, I hope you can hear me at the back. Okay. Oh, very good morning to everyone. First of all, my profound thanks to CRS for this award, and thank you very much for inviting me for giving this talk. Okay, so let me give you very brief insight on the type of work that we do at IISER Pune. So we consider spins as quantum workshop. Okay, so in the next 10 minutes or so, I'll be explaining how spins can be used as quantum workshop. Okay, all right. So the systems that we are using, they are like this. So they are called nuclear magnetic resonance. I will explain this in the next slide. They consist of molecules, and they are placed in very strong magnetic field. That's one system, that is nuclear magnetic resonance. And we also have another platform. So this is called nitrogen vacancy centers in diamond. Okay. So here, this is also similar to the spin architecture. The difference is the following, that depending on the state of the spin, these diamond defect centers, they do fluorescence. So if the spin is in one state, say in state 1, then the fluorescence is less, and if spin is in 0 state, the fluorescence is more. So this allows optical detection of spin states. Okay, so we have these two platforms, and using these two platforms, we can study variety of things. We are physicists, we are mainly interested in the physics of quantum systems. So we can study physics of quantum information in quantum computing, and we are interested in quantum control, so which means how best we can control these quantum systems. And we are interested in quantum simulations, so that's the idea of Feynman. And we can also study various quantum transport and many body effects. I'll give some examples. And we can study really quantum foundations, so the really basics of quantum mechanics. And we can also include various types of machine learning into all these works. So these are the various aspects that we can study using this quantum workshop with the help of spins. So now that's our lab. So we have many NMR spectrometers. So this is the panoramic view. We have about 6 NMR spectrometers. And so this is the Nitrogen Vacancy Center lab at IISER Pune. Okay, so now, okay, so using this, so this is, just a second, it's going out of. Okay. So now just one slide introduction to spin qubits. So we say spins as quantum bits. The reason is as follows. So we take a sample consists of molecules, and inside the molecules we have atoms, and we consider molecules which are diamagnetic. So there are no net electronic magnetic moment, so we can look at only nuclear magnetic moment, so we call them nuclear spins, and these nuclear spins are inside the sample, right? And then we put the sample in very strong magnetic field. How strong? These are like 10 to 20 Tesla, really strong magnetic field. And then what happens is these spins interact with the magnetic field via Zeeman interaction, and if it is spin half like hydrogen, then there will be 2 levels. The ground state corresponds to the parallel, the magnetic moment parallel to the magnetic field, and the excited state corresponds to the magnetic moment aligning anti-parallel to the magnetic field. So that's the magnetic field. We have parallel spin and anti-parallel spin, and they have an energy gap, and that is the Zeeman energy gap. Now this Zeeman energy gap happens to be in the range of the energy of the radio waves. Radio waves are also electromagnetic waves, and that energy happens to be same as this Zeeman energy gap. And so if we can shine the resonant radio waves on this sample, then there will be resonant absorption by the nuclear spins. So they can absorb, not only that, they can undergo the quantum transformation, the unitary dynamics. So we can prepare very interesting quantum states, and the good thing about nuclear magnetic resonance is that such a superposition state lasts for long time. They can retain that quantum superposition state for long time. And not only that, during that time they also emit very, very characteristic signal, okay, that is called NMR signal. And that signal is picked up by this coil here, and that is amplified, and that is sent to the computer. It is digitized and sent to computer, and that is stored as NMR signal. So that's the nuclear magnetic resonance, and depending on the state of the spin, if the spin is parallel, we can call that as 0, so that is 0 state, and if the spin is anti-parallel, we can call that as 1. So now you see we have a binary information encoded on the state of the nuclear spin. So 0 and 1, so that's a binary, it's a bit. And since it's a quantum system, we call this as a qubit, quantum bit. Now using such a system, we can do variety of things. For example, now instead of one spin, we are here considering a molecule. This is just L-histidine, and in this there are about 11 spins plus there is one extra. So we call this as a 12 qubit system. So we have now 12 quantum bits, and each of these rectangles here, so they are very, very specific resonant radio wave applied on that particular spin. Okay, so we have various resonant RF pulses here, and these introduce very, very specific dynamics, transformations, unitary transformations. And each of these are called, each of these pulse introduces something called quantum gate. Okay, so now we have quantum bit, and we are applying a quantum gate. It is similar to what you study in electronics and computer science. So we have bits and gates. So here also logic gates. So here also we have quantum bits and quantum gates. And together they form a quantum operation that is called quantum algorithm. Okay. So by doing this quantum algorithm, we can take the initial state to some specific output state. So from input goes to output, and that output is finally read out by the NMR signal, and that forms quantum computation. Okay, so we have done quantum computing in this. And this specific algorithm is called benchmark quantum algorithm. And so now we can do variety, we can take variety of systems. For example, this is a 12 qubit system, 18 qubit system, 38 qubit system, and so on, and do variety of computational tasks. Just to give some example, what all we can do. So this is one interesting example. This is called Leggett-Gerg inequality. Leggett is that Anthony Leggett, Nobel laureate. So he proposed that there is a way to determine whether a system is behaving in a quantum mechanical way or in a classical way. And there is also a phenomenon called decoherence. That means if you prepare quantum superposition, slowly it loses out superposition, quantum superposition. So slowly it loses that quantumness, and ultimately it becomes classical. Now the question is, when, until what time the system is behaving quantum mechanically, and then when is the emergence of classicality? So this can be probed by studying Leggett-Gerg inequality. And Leggett-Gerg inequality can be studied using such kind of systems. So in this case, we just took chloroform. And so we have two spins here, carbon nuclear spin and hydrogen nuclear spin, which is just proton. And we can measure experimentally the correlations. And after measuring the correlation, we can determine so-called Leggett-Gerg string. So that is the K3 string. So we can evaluate that K3 string as a function of time. So this is milliseconds. So as a function of time, so that is converted into angles. So now now there is a Leggett-Gerg bound. So that is this here. So this is 1 here. So if it exceeds 1, then we say that it is quantum mechanical. If it is not exceeding 1, it is classical. So you can see that up to about 165 milliseconds, the superposition is having that quantumness according to this Leggett-Gerg inequality. So we see that as a function of time, due to decoherence, the classicality is emerging from the quantum superposition states. So this is one example. This is a very nice fundamental exploration of emergence of classicality in quantum system. So recently we extended this using something called superposition of quantum operations, and that made further improvement in the study of Leggettker inequality. I'll not have time to describe all the details, but then this received a lot of attention. For example, American Physical Society made a viewpoint on this, and this is called one of the breakthrough research in the last year. Okay, so now another example. So we all know that light behaves like sometimes as particle, sometimes as wave. So now can there be in between? So partially wave, partially particle. In fact, that is possible. Light can behave not entirely as wave, not entirely as particle. It can be in between. It is neither completely wave nor completely particle. So that can be demonstrated. So this is called quantum delayed choice experiment, and this was proposed by these Australian scientists in the year 2011, and we were the first to demonstrate it experimentally. So we showed that nuclear spins can behave like entirely particle or entirely wave or in between. Okay, so we can smoothly vary the nature from particle nature to wave nature. So these are the explorations in the foundational aspects. Back in 2018, we experimentally studied another interesting phenomena that is called time crystal. So it is also very interesting, even from the application point of view. So we know crystals have spatial order. Time crystals have temporal order. Okay, so that's a time crystal. And so this was very interesting, and it was proposed in 2012 by Frank Wilczek and his collaborators, and again he was also a Nobel laureate. And so this initially created a lot of controversy, because some people said physics doesn't allow such systems having temporal order, but we showed that experimentally such systems can exist. So this is such a phase of the system can exist, and this is the experimental demonstration of time crystal in NMR using such a system.
Sorry, sir. Interrupting you. 5 minutes left.
Sure. Yeah. Okay. So now, just to show one example of another application. For example, recently we demonstrated quantum battery using such a system, and this quantum battery can last for 2 minutes now. So we have really a system which can store energy. It's a quantum system that stores energy and that can hold the energy for 2 minutes, and it can give the energy to the load. Okay, so if you have any applications, in fact this can potentially have medical application where the drug stores energy and dumps it to some target cells. So that's a quantum battery. And so we can also realize large number of qubits using solid state NMR, and I'll skip this in the interest of time. So this is one example of nitrogen vacancy centers. So NV centers come in 2 species, NV0 and NV minus. So this is the first time we could image in the diamond NV center which parts are NV minus and which parts are NV0. So this is a image of the species in the diamond NV centers. Okay, so our research goals are like increasing the quantum memory, and we also want to hybridize NV center and NMR, and we want to improve the performance by improving memory, improving the register size, and also improving the sensitivity. Okay, so that let me summarize now. So as I said, we are interested in studying the physics of spins. So we want to treat spins as quantum workshop, and using that we want to study quantum information, quantum control, quantum simulations, many body effects, and quantum transport, quantum foundations, and machine learning. Thank you very much. Yes. Yes. You are right. No, I'll be happy to discuss.
You know that he is awardee, we are honoring him.
Directly onto my presentation, I would like to thank Professor Bag and Professor C.V. Yalamagar sir and his complete team on recognizing me for this prestigious CRS bronze medal and giving me the platform to present my work here. And also to VC sir, Registrar sir and his complete team from Saurashtra University for organizing this event in so managed way. Thank you so much. So, currently, I am associated with the TNB College, Bhagalpur, but before that, I was associated with Sharda University, Greater Noida, and much of this research part has been carried out at Sharda University. So, this is an approach to combat hospital-acquired infections, and it falls under SDG, Sustainable Development Goal 3, that is good health and well-being. So, what are hospital-acquired infection? Giving you a brief introduction about it. So hospital-acquired infections are infections that patients acquire while receiving treatment in healthcare facilities that were not present at the time of admission. So globally, the accepted rate for HAIs is up to 8%, but in India, at least 18% patients, they are getting HAI. So this can be because of the ventilator-associated pneumonia, or it can be because of septicemia. 25% of it is transmitted through surgical site, and 40% urinary tract infection. So the major transmission route for these infections can be direct contact from person to person, or through formites, contaminated surfaces, or medical equipment, or it can be airborne. And major common HAI pathogens are bacteria and viruses, and they have the ability to survive on the hospital surfaces for months. And after COVID-19, this has become a major area, a hot area of research to talk about. So we have taken it up as the research problem, and we tried to find out the solution, what we can do with these to prevent these hospital-acquired infections. So we came up with the solution of antimicrobial coatings. So antimicrobial coating is an application of a chemical agent that stops the growth of disease-causing organisms. And antimicrobial coatings can offer a continuous solution to reduce surface contamination between regular cleaning cycles. So we came up with the solution. For this, we have used metal oxide polymer nanocomposites, specifically ZNO PVP nanocomposites. Why specifically ZNO and PVP? Because ZNO is well known for its antimicrobial activities, and they can be used for coatings because they are environmental friendly, cost effective, and they have multiple antimicrobial mechanisms and long lasting activity with low toxicity to humans. So the multiple antimicrobial mechanisms available with ZNO nanoparticle is they have tendency to generate the reactive oxygen species. They can release ZN2 positive ions, and they can have the direct membrane interaction, because the ZN2 positive is positively charged and the bacterial cell wall is negatively charged. So it has the tendency to eventually kill the cells of microbes. And why PVP we have chosen? Because PVP is a biocompatible polymer. It is non-toxic and approved for medical and pharmaceutical applications, and it forms film easily. So role of ZNO in nanocomposites is it is acting as a dispersing agent. It provides the surface modification. It helps in matrix formation so that nanoparticles can sit inside it. It helps in controlled release of ZN2 positive ion, because leaching is the major issue in these antimicrobial coatings. And why we are focusing, what are the major things we have focused while deciding this solution and while preparing the coatings is, this is a major published studies, they stopped at the characterization. We have taken it forward for the application for this antimicrobial coatings. Already published work, they have emphasized on optimizing one property. Either it is antimicrobial or UV ray protection or anti-fouling properties. But we have gathered all together and tried to find out the solution to make a coating with all these properties. We synthesize the coating with green synthesis, antibacterial and anti-fouling properties, superhydrophobic surfaces, and with self-cleaning property. So this is the methodology. Yesterday also, few of the lecturers who discussed about nanomaterials and nanocomposites, they talked about the green synthesis. So we have utilized here the green synthesis for the synthesis of ZNO nanoparticle. The green synthesis is done with the help of rose flower extract. And rose flower comparatively is costly, but the theme behind it is a lot of waste is discarded from temples. The rose flowers are discarded from the temple, so this waste can be utilized wisely in preparing these nanomaterials. So that is why rose flower is used for this, and they are mixed with PVP in a solvent, and then continuous stirring is done and heated at 60 degree to 80 degrees centigrade. We got the precipitates which are being centrifuged at 1000 RPM and then dried and received the nanocomposites. Just to give the glimpse of the methodology, I have prepared that slide, and that characterization, we have characterized the material different techniques, and coming to the XRD pattern, it reflects the crystalline structure of ZNO, and the major peaks, these intense peak, it shows the ZNO crystalline structure. Coming to the UV absorptions, UV visible spectra, this is the ZNO, bulk ZNO, it shows the peak around absorbance peak around 370 to 385 nanometer. But there is a shift in the peak from there to 359 nanometer, which is a significant blue shift, showing the quantum confinement effect because of this shift, and showing that these nanoparticles, they are well trapped at the nanoscale. And this, when they bulk ZNO, it appears at 385, around 385 absorbance. It shows its normal band gap of 3.37 electron volt. Here, the band gap is calculated through Tok plot. It has reduced to 3 electron volt. This FTIR spectra, the lower range of peaks, they are showing the ZNO stretching, ZNO stretching, and these 3 peaks, they are confirming the presence of PVP. And there is a shift in the peak of PVP. The normal peak of PVP, the pure PVP, it shows peak around 1650 centimeter inverse, but here we are getting a peak around 1609. That means there is a coordination between the oxygen present in PVP with the positively charged Zn2 plus ions. So this well defines the formation of the nanocomposite with a good coordination between Zn2 plus and oxygen. So it these
Sorry,
are the
madam.
yes.
5 minutes left.
These are the SAM micrographs which are taken at different magnifications, and they show the broad plate-like and rod-like structure, and it shows the rough irregular structure but well dispersed in the matrix. So this uniform dispersion in the matrix and this rough and layered structure, it shows, means it increases the exposed area, which creates a number of active sites for antimicrobial activities. And it also, this rough surface also adds to the hydrophobicity. So why hydrophobicity? Because the coating, they should have 2 major parameters we are taking care, the antimicrobial activity and hydrophobicity. Antimicrobial part is taken care by ZNO, and hydrophobicity, for hydrophobicity we need surface roughness as well as the contact angle. So if the surface roughness we have shown with the help of SEM, and for the contact angle, if it is above 90 degree, theta is above 90 degree, then it is hydrophobic, and if it goes 150 or more than 150, it becomes super hydrophobic. So we have done the contact angle studies on the hydrophobic surface, and this is when we have applied 1 coating, then it is showing an angle of 87.6 degree, 2 coatings 95.4 degree, 3 coatings 98.62. Means the coatings, the number of coatings, they have increased it from hydrophilic to hydrophobic part. So that is why that is making the surface hydrophobic, solving our purpose. Main point to be taken care here is the ratio between PVP and ZNO. This is the major task we have taken here, means the major time we have spent in optimizing this concentration, how much is PVP required and how much is ZNO required, so that we can make the surface hydrophobic. So coming to the studies, antimicrobial and anti-fouling studies, and I thank my collaborator Dr. Soumya Pandit, Department of Biotechnology, Sharda University, for conducting these research. For this film form, development of biofilm is done with the help of confocal laser scanning microscopic technique. These are the CLSM images, where different ratios of ZNO PVP are being tested, and when they are being tested, the different you can see as the concentration of ZNO PVP is increased, the anti-fouling is eradicated. There is no anti-fouling taking place on the surface. And this is the XTT assay which is showing the antibacterial studies. In this what happens is we add XTT to the equimolar concentration of ZNO PVP nanocomposite as well as the bacterial solution, and they form formazan. It is a colorimetric technique, and if we have viable bacterial cells, they show absorbance. So this is the maximum absorbance when we have not used the nanocomposites, and as we are increasing the concentration of nanocomposites, it is leading to the death of the cell. So this is this is in support of the antibacterial studies. So this is the demonstration of the self-cleaning properties of the hydrophobic coating. The coating we applied, it was clean deliberately we have added the particulate matter over its surface, and so that we can create the means we can make the surface visible for environmental contamination, and when water is flowed over it, we can see that the coating got clean. So it is because of the irregular surface, irregular morphology, and hydrophobicity of this layer, which is leading to non-adhesion of the dust particle over this surface, and with the flow of water, the water is not distributing uniformly. It is coming out in the form of drops because of the hydrophobic nature of this film. So less water is required. It is showing self-cleaning property, and this self-cleaning is very, very important in this hospital environment because to maintain the hygienic conditions. So conclusions and takeaways are the nanocomposite coatings are prepared with multiple mechanisms, and we have integrated PVP with ZNO, and this is cost effective alternative. We have checked the different alternatives, silver, TiO2, they have all ecotoxicological effects, but this ZNO is not having ecotoxicological effects because it is a important nutrient. And we have the potential to significantly reduce pathogen transmission from hospital wall surfaces. My future directions are we have to increase the contact angle because our motto is to make it super hydrophobic so that it can be washed. We did not require even water, it can be flown away with the air flow. And we want to enhance the photocatalytic activity, and we are looking for long-term clinical studies, comprehensive evaluation of efficacy in reducing HAI rates in real-world hospital settings. With this, I would like to acknowledge my collaborator, my research scholars and project students, and Professor A.K. Tyagi, Dean HBNI, and Professor N.B. Singh, Emeritus Professor, Sharda University, the torch bearers, and my research guides. I take help, and they help me a lot in getting the directions, and principal and colleagues from my college, and most importantly, the complete team of CRS Awards and Saurashtra University, Rajkot. Thank you so much.
Namaskar and good morning to one and all present here. It is really a matter of pride and privilege for Saurashtra University to welcome Professor Shivram, who has been internationally acclaimed scientist in the area of polymer chemistry. From the slide you can see the achievements. Did PhD from Ohio University, US, postdoc in Yale University, 100 plus patents on his name, and over 8,000 citations. He is an internationally acclaimed polymer chemist whose pioneering contribution to polymer sciences, catalysis, and sustainable materials have profoundly influenced both scientists and industries. He is pioneer director of NCL, National Chemical Laboratory, earlier, and then he was heading the CSIR labs as well. One of the most outstanding, you can call it, is a Padma Awardee, Padma Shri from Government of India in 2006, and list goes on. Really, we cherish such kind of personality on the campus, and because of this CRS, it is possible that we could able to host them. And sir, I welcome you for this talk. Thank you.
Yeah. Okay. Thank you. Why don't I request some of the people who are sitting in the rear to come in the front? I always like people to occupy the front seats. This going back is, I don't know why we all want to go back. Okay, please come in the front. There's so much seats vacant. I can see you better. And you can see me better, you can hear me better. Come, please come. You know, students have this tendency to occupy the last seat, thinking that the teacher will ask some questions to only the front row people. But I assure you, I'm not going to ask any questions to you, okay? On the contrary, you can ask questions to me, okay? Please come. Thank you. First, at the outset, let me thank the organizers of this event, the Honorable Vice Chancellor of Saurashtra University, for sparing his time to be here in this audience, to the organizers of this event to have invited me to come this morning and speak to all of you. I'm sorry I could not come on the first day for certain other reasons of commitment, but they insisted that I should come at least one day. So I said I'll come on the last day. And maybe some of you have stayed back to listen to me, so it's good for you. Otherwise, people tend to leave on the last day, you know. So, okay. So, thank you so much for this invitation. And thank you also for recognizing me. You know, Lifetime Achievement Awards in this country means that you have done everything. Now you can rest at home and get your awards, you know, lifetime achievement. Because in India, lifetime achievement means now you rest at home, okay? You know, you have done your lifetime of work. There's nothing more for you to do. But I don't think like that. I think I still have many things to do, okay? Although I will not tell you how old I am. So, but I think life is a perpetual learning. I have lived my life, 60 years is what I am today after I began my independent research. It's been 60 years in this country, and what I've learned is science has changed, chemistry has changed in the 60 years that I have lived, but one can stay current. How does one stay current is basically by continuous learning. And I think I want our young people to understand that, you know, learning can never stop. Learning stops on the day you breathe your last breath, okay? On that day, the learning stops. So I think we must have the discipline that learning is something that we keep doing all the time. Since you asked me that this should be a Lifetime Achievement Award, I would like to acknowledge, therefore, a little 2-3 slides of philosophy, because that's very important. You know, we can do many things in our science, but I think what matters is what is our attitude to life, okay? So I want to just share with you 3 things that are, 2 things actually, which actually have guided my life. And so I always say that who are we as people? We are characterized by 2 dimensions. One is a being, who we are. Ask yourself, who are you? What are your values? What are your principles by which you live your life? That's what you call a being. So that's my being. The second is, so being is largely defined by the institutions that you are associated with. That's what defines your being. Institutions also include, to some extent, the early years of evolution of yourself in a family. A family is also an institution. So, the second is thinking, which is the second dimension that all of us have. One is being. Being everyone has. We are all somebody who are born to do something in this world. The second is thinking. Thinking is the power of analysis, learning to ask a question and seeking solutions to a problem. And who gives us this thinking? The thinking comes from our teachers and mentors. They are the people who teach us how to think and how to do things, you know. They are the teachers and mentors. So what I'm trying to say is, if anybody who says, I'm so and so, you have to ask the question, what are the institutions that shaped that person? And who are the teachers and mentors that gave him that power to think? And this is a very simple statement, and I think all of us must kind of put ourselves within this framework. So, in my particular case, you could write your own story, but in my particular case, every institution that I've worked in my life, and as I told you, I've been working for close to 60 years in my life. Every institution that I've worked in my life has created what is called my being, okay? That's my being. And I just show you all the institutions that, how does it go? Just you can turn it, you can switch there, I don't know. Okay, every institution, right from, you can see here, from 1962, I'm very ancient person, I'm, compared to all of you, and I'm a very ancient person, and from 1962, every institution I have spent my life has shaped my being. And similarly, a large number of people who have walked into my life, whom I have encountered in my life, starting from the earliest of my teachers to people who have influenced me throughout my life. Many names and fame, many people's names you may be familiar with, but some of them you may not be. But they have all shaped my thinking, and that's what I am. So I am a composite product of an institution and the people, which gave me the power of my being and my thinking. So the point I'm trying to make is that's essentially what we are all about, and that's what you have to discover. Who are your, which are the institutions that have created you, and which are the people who have influenced you. And these are the two things that, by the way, you will see some people here, whom you, Professor C.N.R. Rao, he was my teacher. He taught me physical chemistry when I was doing my MSc. Professor Herbert C. Brown, a Nobel Prize winner, who was my PhD advisor, and he taught me chemistry, organic chemistry. Professor M.M. Sharma, I don't know how many of you know him. He's one of the most distinguished chemical engineers in this country. I never worked with him, but I had an opportunity to interact with him extensively, and of course, a few other people whom you see here. Some of them are alive, some of them are no longer alive. At the end of the day, therefore, next slide, you can move the slide please. Next slide. What have I learned in the process? I have learned 4 things. How to be truthful, and that's the most important thing for anybody, okay? How to be truthful, okay? Scientists can never be anything but truthful, and please understand that. How to be trustworthy. How can people trust you? How to be humble. Nothing should go to your head, any amount of success. And lastly, as I said, a passion for lifelong learning. So these are the 4 lessons that I have learned in all my life from all these institutions and all these people with whom I have the privilege of having been associated. So thank you for the little introduction. I gave you this in order to kind of set the stage that this is what life is all about. So if I have the next slide, I'll right away jump into the topic of my talk today. And this topic is on porous materials. Now, I don't want to give a lot of introduction. Many of you will understand what is importance about porosity. Porosity is something that is inherently present in all materials, and that's important. It's an important attribute of a material. In fact, the last year's Nobel Prize, there was a slide that I saw in the beginning of my morning, was basically for people who could make what is called reticulous material, the porous reticular materials. And that's what 3 people got the Nobel Prize. Of course, that's a very fundamental definition of a porous material. But I just show you here all kinds of porous materials that we are actually living with today. From very, very exquisitely structured porous material to something which is very ordinary that you use in your bathroom every day, and this is a floor mop. I'm sure you're all using it in your bathroom, here, and this is one of the most exquisite porous material that gives you life. It's your lung, and this is called the alveoli in your lungs, which is actually taking the air and filtering out the carbon dioxide and taking the oxygen inside so that you can live. And that's a porous material, and that's in the lungs, and that's the structure of an alveoli in the lung, which is actually a porous material. So the porous materials are there everywhere around us. I don't want to get into all the details here, but nature produces some of the most exquisite porous materials. Okay, now this is a very interesting thing. I don't know how many of you have seen this. This is called the ring stop leaf hopper. This is actually sits on the leaf. It eats the leaf, and this is, you can find them if you walk around. You will all find them, and little species which are sometimes difficult to detect. It's very difficult. You have to watch very closely before you can find them. Now, what are these? These are insects. And on the surface of the insects are these nanoparticles, which we call brochosomes. And these nanoparticles are actually exquisitely structured explicitly searched, I'm not able to, here, porous materials. You can see here each one is like a ball, like a football, and each of this football has got this nice pores. Okay? Now, the physicist will tell you that if you have this structure right away, you have no reflectance of light. Okay? And this is a classic material. That's why this species is very difficult to see. You have to see it carefully on the species. Because of this structure on the surface, there is no light reflection. Okay? And nature has created this to protect the species. Okay? And therefore, there's no reflection of light. Apart from that, this structures also repels water, because they can stay on the leaf even on a rain, and they will not be affected. Okay? And that is a very great understanding of this material, that today a lot of work is going on to replicate this structure in the laboratory. Okay? Because if you can do that, you can make waterproofing material, you can make camouflage, stealth materials, self-cleaning surfaces, data encryption, and even anti-counterfeiting devices. So that's the basis. So that's what nature, a small ugly looking creature, has created for us. And that is an inspiration for people to create new types of porous materials, because they have got so much of interesting applications today. But the question is, how do we replicate that structure in a laboratory? And that's a question that one can ask. Well, if I have the next slide. So we have been engaged in porous polymers. I am basically a person who has been working in polymer science. And we have been engaged in looking at porous polymers for the last 15 to 20 years. Several PhDs, close to 7 or 8 PhDs, who have worked on this topic with me in the last 15 to 20 years. And we have looked at a variety of methods of making porous polymers, and also a large number of applications of porous polymers. And I will not be able to talk about all of them today, but I'm going to just give you 3 examples. One which is about 10, 12 years old, one that is about 4, 5 years or 6 years old, and the one that is about 3 years old. So I'm trying to give you a kind of a journey that I have undertaken with porous materials in the last 15 to 18 years. So it's a very short summary. I'm not getting into the detail. Many of these are published. So if anybody wants to go, and you can read them in the papers. But if anybody wants to have more information, I'll be happy to provide you anytime. So next slide. So the first thing I'm going to be talking about is a class of material which is called superabsorbent polymers. Polymers that can absorb water in very high quantities, something like 300 to 400% the weight of the polymeric material. These are very well known. So I'm not saying that I discovered this. These are very well known. If I have the next slide, you use them every day. Okay? Your baby diapers, many of you who have children must have used a diaper. Human incontinence products, many people, old men and women, have incontinence and they wear a diaper. You probably have feminine hygiene products that we are all using, which is again to absorb liquids. And of course, in all your cars, you have an oil filter. And I'm sure you change your oil filter once in a while when you take it for service. And that is also a material which is a superabsorbent polymer that separates oil and water, okay, in a filter. So all these things are very well known material. What is that material that we use today? We use polyacrylic acid in the form of a salt, which is a sodium polyacrylate. Why do we use this material? How does it work? 1 minute introduction to the chemistry of its mechanism of its action. A polymer like this is a polyelectrolyte. It has a positive charge and a negative charge. It's a polyelectrolyte. It has a positive charge coming from the sodium, the negative charge coming from the carboxylate anion. Now, in the solid state, because of you need to get electrostatic neutrality, the polymer is completely coiled up. In order to get complete charge neutrality, the polymer has to be completely coiled up. When you put it in water, of course, you get relaxation of the chain because the water hydrates the iron, right? The water will hydrate the iron. When the water hydrates the iron, this chain unfolds, and we call it the uncoiling of a coil. Okay, this is exactly what happens in proteins. Okay, basically the protein unfolding is also a phenomena that is driven by hydrophobic effects, hydrophilic hydrophobic effects. It's the same principle but in a synthetic material. So a very compact structure which is in the form of a powder. When you add water, it gels into a gel, okay, because the water hydrates the sodium ion and then it expands the sodium ion, so the chains start now relaxing and they open up, and we call it uncoiling. And in the process they soak water. Typically a material like this will soak about 200-300% water. I mean, for 1 gram can absorb about 200 grams of water. Okay, and that's why this is used in all these applications. But what's the problem? The problem is this is driven by electrostatic or ionization phenomena. Therefore, just imagine I put some, let's say, sodium chloride into this water. What will happen? My physical chemistry student should tell you now this process should reverse, because it's called the common ion effect. You must have all read in physical chemistry what is called the common ion effect. So you put in sodium chloride, that means you add sodium, it will reverse itself. And therefore, this kinds of material work in neutral water very well. But you increase the ionicity of water, the ionic strength of water, they don't absorb water as much, okay, because its capacity will reduce, all right. So this is simple physical chemistry. I'm sure many of you have read in your university physical chemistry. But the point is, human fluids, whether it's urine or blood or anything, is not at neutral pH, okay. It is all in alkaline pH. And that alkaline pH of a human fluids will differ from people to people. It's not uniform. And therefore, these products may not work for everybody with the same level of comfort, okay. For some it may work, for some it may not work. And the people who feel the wetness of this product are the people whose ionic strength of the fluid is not necessarily something that is compatible with this mechanism. Now, therefore, people are looking for solutions where I should have comfort in wearing such products which is independent of the alkalinity of my body fluid. That means, irrespective of who I am, I should be able to have the same level of adsorptive capacity. That cannot be accomplished by this kinds of polyelectrolytes. So that's why we started looking for an alternative method, and that started the journey. I will complete this journey in 2 slides, but it took us 8 years, okay. So the only 2 slides I'm going to talk about. It took us 8 years of work to take it from the lab to the commercial market, and I'm telling you that. So next slide. And we developed used a method which is called high internal phase emulsion polymerization, and this is a polymerization where we have an oil in water emulsion. This is a monomer, this is the water, the continuous phase. We pack these droplets, which are spherical droplets, which is theoretically, if it is spherical, I can pack as much as 74% in an oil. This is theory. If I have a round balls of a given diameter, 74% by volume I can pack. This was actually talked to us by Johannes Kepler in 1660. It is called the Kepler's conjecture. He proposed this, but actually it was proven mathematically in 1984, okay. So that was the difficulty in proving it mathematically, but now it is a mathematically proven principle that you can pack 74% of a spherical particle in a liquid. Now, if it is not absolutely spherical, the 74% will decrease to maybe 68%, depending upon the size, the changes or the variance in size. So if you can pack an oil in water in the form of a spherical particle, which you can do through micellization today or emulsification today, and I polymerize this under these conditions, I actually get a network. And from this network, I evaporate the water. Therefore, what do I get? I get the pores. Okay, I get a network which is now swollen with water. I evaporate the water, and wherever the water was located, that's where the pores are created. And that's how this is done. Now, again, I will not get into the detail. Take me to the next slide, please. And I'll show you how we do this. We create an internal phase emulsion with acrylic monomers, and we polymerize it. We call it polyhype. It's called the high internal phase emulsion polymerization. And then we remove this water, and you start getting pictures in an SEM. This is a porous polymer now. So this polymer has a porosity now. Okay? You can create all kinds of porosity depending upon how you do this chemical reaction. So I will again skip the details. If I have the next slide, so that's what we did. These are all acrylic material, no ionic charge. Okay? It is just porosity. All right? And we can create, go to the next, keep pressing the button. Yeah. So what we did was we basically created two types of polymers simply by changing the reaction condition. One has very small pores and one has very large pores. Okay? So this is just by changing the parameters of the reaction. And then what we did, we took this layer 1 and layer 2 and made a hierarchical structure in which the layer 2 is basically this one is this one. So what we have done is basically created a sandwich structure. That's what we did. Now, those of you who understand physics or some amount of capillary forces will understand that if you have this kind of a structure, this works like a blotting paper. Okay? It sucks the liquid by purely capillary forces. Okay? And that's what it happens. So you put a drop of blood, the blood will simply suck into this liquid, into the surface of this material. Okay? And this has been now, we spent a lot of time, and this is, we understand this is a combination of adhesion, cohesion, and surface tension, which leads to a differential pressure, which leads to the movement of the liquid. Okay? This is a simple principle that we know from very fundamentals of physics. So if you can maneuver this, you can actually do capillary forces. The capillary forces by which is water is lifted in a variety of phenomena in the nature. Okay? Now, that's a product. We had several US patents. We licensed all these US patents to a company called Procter & Gamble, which is in the US. And we worked with Procter & Gamble for 6 years to convert this idea into a product. Okay, this was just an idea, and this idea was then converted to a product. This product is currently manufactured in Canada at a Bellevue plant of Ontario, and apart from they paid for all my patents, they also paid for a lot of research that we did subsequently in order to take this product from this conceptual level to a commercial level. This product is available in the market. It's not available in the Indian market because at this price point, they don't sell in the Indian market. They sell many other products in the Indian market. But if you go anywhere in the world, you will see this product. This is a feminine hygiene product called Always Infinity. And this is something that you can buy in the supermarket shelf. And that is made of this class of material. It is not made of the polyelectrolyte. And therefore, people who wear this, they have enormous amount of dryness and comfort because their body fluids the performance of the super absorbing capacity of this material is independent of the pH of the body fluid. So so we started, it's 5 minutes. Oh my God. Okay. You please give me another 5-10 minutes, okay? I'll complete it. Okay. All right. So I will skip this, go to the next one. I think I've spent a lot of time. One more quick thing I'll talk about. We then moved into another area some years ago. We thought porous materials are also useful in batteries. And I don't know, many of you may not know that every one of your batteries, your mobile phone batteries or any battery that you use have to have a porous separator, which separates the cathode from the anode, and that's required in order to prevent the shorting of the cathode and the anode. So that's a porous polymer. So if we just go to the next slide, I'll quickly, and that's a porous material which is located in a battery, and this is commonly made of polyethylene and polypropylene today. Okay, the same material in which your shopping bags are made. Okay, it's the same material, but your shopping bags are not porous. this is porous because it has to allow for lithium ion diffusion. Okay. Now, to cut the long story short, this polyethylene and polypropylene have problems, especially in what is called large format batteries. Batteries are basically exothermic devices. There a lot of heat is generated in a battery. Okay. Now, your separator membrane is an organic polymer, and that organic polymer has to withstand that heat. And many of the polyethylene and polypropylene are semi-crystalline material, which kind of the crystalline melting point is about 160 degrees, and therefore around 200 degrees the entire structure collapses. And that's one of the reasons why batteries catch fire. Apart from the fact polyethylene and polypropylene are hydrocarbons, they're extremely flammable. And that's one of the reasons why your batteries catch fire. Therefore, there's a need to look for materials that are more resistant to both temperatures and which are intrinsically flame retardant, which do not burn. And that was a quest that took us into a material. The material was known, but the application of that material in this area was unknown. So we started looking at that material. Go back to the next slide quickly. I will skip this slide, go back to the next slide. And this class of material is a class of organic polymer which is called polybenzimidazoles. Okay, polybenzimidazole has been known to us for the last 60, 70 years. But the point is that I need porosity in polybenzimidazole, because dense polybenzimidazole will not work as a separator. I need a porosity for the diffusion of the lithium ion. The lithium ion has to move from the anode to the cathode, and that's the only way the batteries will work. So our quest was, how do we create porosity in polybenzimidazole? And this was a project that took us about 6 years. Okay, our work, 3 PhDs, how to generate porosity in polybenzimidazole. That was a lot of work, which I will not talk about it today, how we did it. I'll just show you one example if I have the next slide. And this example is one way to create porosity in polybenzimidazole is to choose structures which are intrinsically contorted, which have got an sp3 carbon. An sp3 carbon is completely locked in a conformation, which is what we all learn in organic chemistry. It's completely locked in a conformation without any mobility. And therefore, if you have this carbon here, you see here this is an sp3 carbon. Or there it is a 2 benzene ring connected, you are locked in the conformation of the benzene ring. The benzene ring cannot have infinite conformation. And if you do that in a chain, in a polymer chain, if you introduce a small amount of these comonomers, wherever these comonomers come, the mobility will be impeded, the mobility will be inhibited. Otherwise, a polymer, an amorphous polymer, has at least above the Tg a substantial amount of segmental mobility, and that mobility can be restricted by mechanically introducing certain chemical entities. And that's what we did in the lab. We synthesized, we analyzed, we characterized all those things, and we showed that such things create what is called intrinsic porosity in polymers. Anyway, that's again a long story. If I have the next slide, I will not bother you with all the chemical structures. If I have the next slide, go back. Next slide, next slide. Next slide. See here, you can do a simulation. These are actually simulation on a computer. This is a dense polybenzimidazole. You put in these kinds of monomers, you see it's opening up. You see the space opening up? And the space is opening up because we call it the free volume in a polymer chain. The free volume opens up because of the fact that wherever these kinds of monomers are entering the chains do not have what is called infinite conformation, ability to assume infinite conformation. So they're restricted conformational mobility. It creates a kind of a pores. And so you can see here expansion, and this is through a parameter called the radius of gyration. And this is something that we can measure, through computational method. This is not done through experimental method, but we have also measured it through experimental method independently. If I have the next slide, all these things have been published, patent. Made a batteries out of them. Okay, we kind of replaced the existing separators. We made the batteries. We showed them that you can actually make batteries with good performance. And if you have the next slide, we wanted to understand how does mobility happen in these kinds of thing? Because you have a very polar polymer here, which has an ability to transport lithium ion from the anode, from the cathode to the anode. So we looked at a lot of parameters to study, and we all studied this using lithium-7 NMR. And basically we use both liquid state and solid state NMR in order to study. And we do a lot of what is called diffusion experiments in NMR, where we can actually track the movement of the lithium ion across the membrane. And this is done in an NMR environment with my collaborators who are experts in NMR. And we showed that there are certain species that are formed which are ion pairs, which have a very important role in the transport of the ions across the membrane. If I have the next, push the next button. In fact, one of the things that we came out with was all battery people, all lithium ion battery people use a 1.2 molar concentration of lithium hexafluorophosphate in ethylene carbonate, dimethyl carbonate. It seems to be a magic concentration everybody uses. And our study has now established why this is such a great concentration to work with in a battery, because this gives you the optimum concentration of what is called the contact ion pair and the solvent separated ion pair in the lithium in the lithium complex with the solvent. So this is an interesting insight into the mechanism of diffusion. Anyway, if I have the next slide, I don't have time to talk about. We have now come up with from a theory, from experiment, we have come up with a theory, how does lithium ion move across a membrane of polybenzimidazole. Okay, again, for those of you who are really interested, next slide, who are interested in seeing this, you can read some of these papers in the journals today. This one has just appeared last week, the influence of porosity of polybenzimidazole separator membranes on lithium ion diffusion and local mobility. So this is something that you can now, you can go and read the details if you're interested, but this is something that we have now kind of published many of these papers now in the literature. Okay, if I have the, and give me a few more minutes and I'll conclude. The last slide, last 3-4 slides that I want to present. If I have the next slide. Okay, these are the people who helped me to do all this work. My colleagues in NCL, the colleagues who did all the NMR work for us, people who do the computational measurements, and I also did a lot of positron annihilation spectroscopy in BARC on these materials done by Karthi Sudarshan in BARC Mumbai. So that's all the people who have kind of helped me to make, kind of create my understanding of the subject. If I have the next slide. Okay. A few years ago, and this was just 2-3 years ago, I got introduced to a new material, which happened to be a natural material. It is not synthetic material. And this natural material, if I have the next slide, grows in Bengal. Okay? And those, are there Bengalis here? Maybe. Any Bengali here? Oh, okay. So you know this place, you know this? Okay. So all the people who know, who are in Bengal will know that this is a very interesting material which is called the shola. Okay? And this grows wild in Bengal. And I was fascinated by this material during one of my many visits to Bengal. I traveled extensively to Murshidabad, to Sundarbans, to a variety of places, looking at how this grows. And I was very fascinated by this material. So I went and interested some of the colleagues to let's look at this material, okay? This material is a very important part of the culture of Bengal, okay? A very important part of culture, not only Bengal, Orissa, Bangladesh, that part of the world, okay? And if I have the next slide, it is something that grows in many parts of Bengal. We have actually done extensive studies in Sundarbans, The interesting part of this material is it is a very rapidly growing wild species. You plant in the month of June, you can harvest in the month of August. 3 months, it fixes carbon dioxide. To the best of my knowledge, this is one of the fastest fixers of carbon dioxide. Okay, now I don't know how many of you are today aware that fixing carbon dioxide is one of our biggest challenges today. And how do you fix carbon dioxide quickly is going to be a very important challenge in the whole quest for global warming. This is a plant species which fixes carbon dioxide. It fixes biomass. Now, it's one of the fastest biosynthesis. Right now, we are actually doing a study on and really determining the photosynthetic kinetics of this material with botanists. We are working with the people in the School of Agronomy in Kalyani University and trying to figure out the rate of biosynthesis of, that means fixation of carbon dioxide. Okay, and because we can establish that this is indeed the fastest in the world. Yeah. And this is the species. I will not get into detail. In Bengal, it is more than just a plant. It is a partner in Bengal's cultural history. And many of you know why it is so. I think you must have seen these products in various places. These are all made of shola, crafted by very, very, this is a part of the craft and art of Bengal, and there are very, very exquisite craftsmen who kind of, take this wood and shape them into various forms, which you can now buy in the handicrafts emporium. Okay, what we did was we started looking at the structure of this material, and not to my surprise, I anticipated it to some extent. I can tell you why. These are wonderful porous materials. So now you know where I have come from. Okay, I started with making porous materials in the lab, and now I find that nature has made it, without any chemistry that I have to do in the lab. Okay, I don't have to do any chemistry. I did 6 to 8 years of chemistry to make porous materials in the lab. And nature has been making it for centuries, And this is an exquisitely porous material, but what I want you to see here is this is a hierarchically porous material. You see here a small pore and a large pore. Now you remember how I put together the superabsorbent polymer? Made a small pore and a large pore, and I assembled it mechanically. Here nature has assembled it intrinsically, and this is the beauty of nature. And therefore we looked at many things. We have done a lot of studies on this. These are the first studies ever made on this material in the world. Okay, and we have now done all the tomographic imaging. You can see here it is a essentially isotropic porous material. It is porous all over the place. Okay, so it's not that the porosity is located in some parts. It is completely porous. 90% is the extent of porosity, of this material. And we have done a lot of understanding of the characterization, looked at its molecular weight, because essentially it is cellulose, right? So we have looked at the cellulosic characterization and variety of other tools. It is also a very light material. I call it the lightest natural material known to the world. The density is so low, obviously, because 90% porosity means density is so low. And now you know why it looks white, right? It's all porous. So light, it does not reflect, it is opaque to light, and therefore it looks white. Okay, and so it is essentially 70% cellulose. We have done all the characterization, and the interesting part of it is, can I have the next slide? It is hydrophobic. Now that's surprising for you. Okay, it is plant-based material, but it's hydrophobic. I won't have time to explain to you, but it's oleophilic. It hates water. It loves oil. Okay. And therefore we started looking at applications, because now I have something that it hates water, but it likes oil. Therefore I can separate oil and water. Okay, and that's what we have done, and we can separate oil and water. You have an emulsion of oil and water, I can separate. Okay, and that we have done. I will skip this. There is a lot of work that we have done to prove that we can, using this natural material, we can separate oil and water. This, we have patented this. This is published recently. This is the first scientific paper on shola, which is an Indian natural product. And it is the first scientific paper. Okay? I always believe that in India we should look at our resources, because such wonderful resources exist here. And yesterday when I was coming, I was talking to one of your faculty member of microbiota, and which you are working on in this university. I think that's the important thing. You have so much of natural resources available in this country, and we go and search for nanoscience and nanotechnology in America, and I think this is where nanoscience and nanotechnology is available. So therefore, please look at natural material. There are surprises. There are enough surprises for you to figure out what you can do with them. All right. So this is the first scientific. So if you now Google Shola, this is the paper you will get first. Of course, you will see 3-4 more papers, all coming from the same laboratory. Okay, but this is the first science-driven understanding of what this material is. Okay, if I have the next slide, high cellulose content, low lignin, very amorphous, high porosity. Lots of applications for this. So it's opened up, in my opinion, a completely new world of opportunities, that what we can do for this. I don't have time to talk about it. We have actually made nanocellulose from this, which is nanoparticles of cellulose from this, which are spherical nanocellulose. Okay, which are spherical nanocellulose, about 300 nanometers in size. This is about the way it looks like. You can see that's the AFM picture of the nanocellulose, and this is all made from Shola. And there are lots of applications for this. And we have shown that these are sub-micron size nanocellulose particle, and they are great emulsion stabilizers. I don't know how many of you have read in your physical chemistry. I went back, and it's amazing that this is not something I wanted to look at, but now that I got the idea, I went back and read my physical chemistry again. And I said, Pickering emulsions have been known to us for 100 years, where emulsions are stabilized by nanoparticles. You don't need a surfactant. You don't need a surfactant. You can do it, you can stabilize by nanoparticles. This has been known to us for 100 years. And now we find that we can actually do this. I'll show you one picture which will show you. Next slide. Next slide. Next slide. We make this nanoparticle. No, we make next slide. Okay. See here, excellent pictures. You see here, this is an organic liquid which is red, which is actually cyclohexane, and which is surrounded by the blue particles, which is cellulose. And this is a classic image of a Pickering emulsion. And that means it stabilizes cyclohexane in water in the form of an emulsion. And these emulsions are stable for months. The water and cyclohexane do not separate, because the particles, the nanoparticles of cellulose, which is hydrophobic, is decorating the oil, which is also hydrophobic, but in a phase which is water, which is continuous phase. So it's essentially is acting as a stabilizer. And today with the modern tools, you can see here, you can see every oil particle is decorated by the cellulose particle. And that's how the oil particles don't coalesce. They don't come back together and they coalesce to make large droplets. If they make large droplets, they will separate. Okay? So this is an exquisite way of doing it using a natural material, no surfactant, nothing. And then if I have the next slide, so I said if we can do this, we should be able to do emulsion polymerization. Okay? I mean, that's a very standard technique in polymerization science, and that's what we did. We do emulsion polymerization. Go back to the next slide. Okay? We can make very nice particles of polymers. Okay? Exactly the same thing. We emulsify methyl methacrylate in water with cellulose, and we polymerize, and we get PMMA particles, which is this, which is here. Okay? So these are very nice ways of doing chemistry. I'm having a lot of fun in the last few years. Okay, if I have the next slide. Well, this is published about 2 months ago. It's called Oil in Water Pickering Emulsion and Emulsion Polymerization Stabilized. And you will see in every paper we have written, the word Shola will appear. The idea is that any indexing, anybody who looks for Shola will get these papers. So I have made sure that every paper the word Shola appears. Okay, that's the name that Bengal gave to this plant. Okay, if I have the next slide, we have made thickeners for paints from this. Okay, this I have worked with Asian paints, and we've actually made paints, and we have made the paint which is basically a rheological thickeners. Again, I don't have time to explain the mechanism, but all done with cellulose-based Shola. Okay. Shola-based cellulose particles. Okay. If I have the next slide, you know, some of these things can act as detergents. Okay, I'll skip the next, go to the next slide, I'll show you. Okay, all you have to do is take a soiled cloth, shake it with this nanoparticle, your cloth is cleaned. No detergent is required. Next slide. Next slide. You skip this. This is a mechanism. Good. Okay. Go back to previous slide. See here. I told my students, take some turmeric. Okay. Put it in a cup. This is water. You just wash with water. Turmeric will not go. This you wash with this nanoparticles. Turmeric is gone. This is Surf Excel. Last is Surf Excel. Okay. All right. It's better than Surf Excel. All right. This is oil. That is coffee. You know, all of us spill coffee on our dress, right? So, what? See, this is CNS. This is what's called cellulose nanospheres, and this is Surf Excel. Okay. So it's a detergent. I mean, amazing application. Once you start understanding the chemistry and physical chemistry of this, you can look at every number of applications. Go back to the next slide. So here you see here, I can remove ketchup. You know, they advertise, no, in TV, children have ketchup and they say put Surf Excel. Okay, that's what advertisement for Surf Excel, right? So here, this is water, this is cellulose nanospheres, and this is detergent, which is Surf Excel. You know, this is the performance of you know, cleaning efficiency. All right, and this cellulose nanospheres, I can tell you the mechanism by which it works. You know, it works like a detergent. So, all right. So if I have the next, I think I'm finishing it up. Next slide. He said, if all application is there, all this interesting application is there, we should be able to commercialize it, right? So we formed a company. Okay. Now everybody says startup companies should be started by young people. Okay. But please believe me, startup companies can be also be started by people in the age of 75 and 80. But I will use young people in my company, okay, to drive the objectives. So there's a lady here who starts a company, I know. So I have also started a company, okay. But this company is incubating in Calcutta, ISER Calcutta. That's why I keep going there very often. And this company is called Innovation. We have hired people, we have raised money, and if I have the last slide. So we are doing a lot of things. We are doing things like oil cleaning products. We have made prototypes for oil cleaning. We have made things, you know, just go back. There's a small video. Can you see the video? Can you go back? Yeah, just click on it. You may see a video. Yeah, just click on it. Yeah, just click on this. Does it work? Okay, all right, doesn't matter. It shows you a performance of a product that we are trying to explore. So a lot of small products we are making now in a small environment. Go back to the next slide, and I think that's the end of my talk. And I think everything is being done. You can we also now trying to market some of this nanocellulose to small customers and to see whether they have some application that they can develop from them. So this is something, as I said, in the very last phases of my life, I am having this journey of an entrepreneurship at this point of time. Okay, so if I have the last slide, I think I'll stop here. I'm sorry I've taken a lot more time than you gave me, but it's been a great fun working with so many people in my life across so many institutions, you know, and they have all given me everything that they have. All I have done is just master imagination. The rest of it I have not done. It's all done by so many people, students and young people, master's thesis, you know, students. All I have done is just given them a little bit of that glimpse, said we can do this, and they have done the rest. Thank you so much for your time.
Thank you so much, Professor Sivaramji for excellent talk, and it was so lucid, not being into so many technicalities, yet it has penetrated the fundamentals of chemistry. Really appreciate, sir, and because of the constraint of time, we had some limitation in that, and also because being the awardee lectures, we have prevented all the questions in all the session. But surely that whatever the literature that sir has shown, I think if you can refer that, you will get your answers. Thank you so much, sir. Thank you.
I think he deserves a standing ovation. Really, truly, he inspires everybody, who think that we are super innovated. That is not the case. It's the beginning of another era. Sir, CRS Lifetime Achievement Award tells you that it should begin again. Chair, please.
Normally they believe that you have done everything and therefore you have.
No, sir. CRS is different.
So, I said I still have many miles to go.
Yes, sir. Yes, sir. No, sir. Later, please. No. This is award question. No, please. Sorry. We should respect that. Okay. Now, ladies and gentlemen, yeah, please be seated. Please be seated. Later, we can stand up once again later. So, go back to first slide. First slide, please. Sir, we honored. No, next slide, please. Next slide. Next slide. Yeah, we honored Professor Venki Ramakrishna, Professor Anika Kotkar, and you, sir. And you are about to reach to Nobel Prize. That's what our meaning is. Yes, sir. Thank you. So, on behalf of all of you, CRS, we would like to honor him with the prestigious Lifetime Achievement Award of CRS 2026. Thank you. Sir, I request you to be here to honor others. Yes, sir. Yeah. So, those who missed the first day, I think maybe perhaps lucky because they are going to have their awards with sir. He'll be bestowing award upon you. So, next slide, please. Next slide. Okay. Yeah. Next slide, please. Next slide. Yeah. Now, no, go back, please. Yeah. May I call upon now Professor from, Professor Kodandarama Ramanujam from, IIT Chennai, Madras, sorry. Please.
Next, may we please have Dr. Shubhra Singh ma'am to kindly come forward and take your award. Thank you, ma'am. Now, may we please have Dr. Sunaja Devi, KR, to kindly come forward. Thank you, ma'am. And now our final awardee, Dr. Richa Tomar. Please kindly come forward, ma'am. Apologies for taking much of your time, and we didn't spare you with the tea break today. So now we will part ways for the tea break and we'll regather here after 10 to 15 minutes. Thank you. 10 minutes, yes. 10 minutes sharp.
uh, 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 contributed his work in analytical chemistry, and he is doing some highly expert work in analytical instrumentation also. And apart from that, he is a guiding PhD student as well as BOS member in various universities, and he has also got funds from various national institutes for research. Now I welcome to Dr. Yashwant Singh Ji Jadeja for his presentation. Sir.
Hello. Is it right?
Stage is yours.
Hello. I think I'm audible. So actually, I have only 5 minutes. So I try to explain whatever work that we are doing at Marwari University within a 5 minutes. It's a very short time, but as sir said, I'm associated with the organizing team, so that's why I need to complete it within a 5 minutes. Sorry? Okay. So basically, we are dealing with a different type of aspect of the application side, and different type of molecule synthesizing. Basically, I am from the NMR and single crystal XRD, but somehow I switched my research work toward the organic synthesis, peptide synthesis, and today I am presenting my work with respect to the peptide synthesis that we are doing at the Marwari University. So basically, we are working with a few molecules in which we have just conjugated our molecule, the peptide molecules, with the heterocyclic moiety. Then after we cyclize the peptides, then after we conjugate with the fatty acid, and then also we synthesize some of the decapeptide molecules in our laboratory, and we are getting very interesting results for the molecules. As we know that these peptide molecules are very effectively mimicking the natural biological process. So that's why what happened, it is very important to give the good activity against the different type of target, like for example cancer, diabetic, and all things. This is very interestingly studied by the different type of research team. So generally, if we identify the mechanism of the action, so the peptides which are electrocation, they are very interestingly attracted by the negative side of the membranes. So it is easy to connect with them, and with respect to it will be bind and insert into the membrane, which will lead to give a specific pore formation. And with respect to that, what happen, it will be easily penetrated inside the membrane, which will give a different type of application, like inhibition of the replication of DNA, synthesis of the RNA, inhibition of the enzyme, and it will also give you the modulation signaling with respect to the cell. So with respect to that mechanism, we are identifying very leading molecules which are very effective, give the anti-cancer, anti-diabetic, even the derma-based activity. And with respect to that, we are working with antimicrobial, anti-cancer, derma-based, and the neurological disorder study also, which are we already synthesized, we studied, and few of the things that we are going to propose in our next research. The thing is that we are selected the small molecules. Why small peptides? Why small peptides? Because it is easy to synthesize in the laboratory with liquid phase peptide synthesis, which is very cheaper, where the long peptides, or you can say that the big chain peptides, are very difficult to synthesize. Even the impurity concerns are there, and that's why it is cost effective. So for a researcher in the university, it is better to work with respect to the small peptides. Even you can also synthesize in your laboratory with effective yield, effective purity, and all things can be possible with respect to the small peptides. As we discussed earlier, that the mechanisms shown that the cationic, then hydrophobicity, and all things is required in the molecule. So that's why what happened, we have identified some of the amino acids which have a cationic characteristic, acidic, anionic properties, pi-pi interaction, hydrophilicity, hydrophobicity, and by the selection of these amino acids, we have designed the peptide molecules which are giving the very good effective results. So if we start with respect to our work, so we identify the amino acid to synthesize the dipeptides, and that dipeptides are effectively conjugated with respect to the heterocycle, because as we know that those who are chemistry people, they are know very effectively that the heterocycles are giving very effective results. So after the combination of the small peptides with respect to the heterocycle, we enhance the biological activity, enhance the metabolic stability, also prolong the half-life, and it is also available with respect to the superior bioavailability. So selection of the heterocycles will be carried out like indole we have identified, oxopyrrolidine also identified, thiophene also identified, and tetrahydro isoquinoline we selected, and we synthesize about 50 molecules, and part of 50 molecules, each and every molecule shown very effective results against the antimicrobial activity. But if we identify few of the molecules like indole and thiophene based conjugated peptides, it shows very effective results after the antimicrobial activity compared to the standard drug that is available in the market. Now the thing is that is about the antimicrobial study. We also identified that this peptide are very good in the derma based product. So what we did, we have identified the simple type of amino acid conjugated and prepared a dipeptide. That dipeptide club with respect to the simple fatty acid. Okay, with respect to that, what happened? This fatty acid give the hydrophobic characteristic which is very required for the derma based product. And after that, what happened? The amino acid which will give you the flexibility, and some of the other amino acid will give you the different type of hydrogen bonding, pi-pi interaction, and all things which will enhance the derma based activity. With respect to that, we have identified cell proliferation assay which is showing very good result against the MDA-MB 231, that is the breast cancer, and the normal cell line also, and which will give the enhance the result with respect to the standard drug. We also identify the collagenase inhibition assay, which is showing that the HC, which is very effectively inhibit the enzyme. So that's why what happened, it is showing very good derma based product also. After that, first we have club with the heterocycles. Second, we have selected the amino acid club with respect to the fatty acid, and now we cyclize the molecules. Okay, so cyclic peptides will give you a different type of application like structural stability, enzymatic degradation, half-life improvement of the half-life, target affinity, and the greater potential for the drug discovery. Like recently, those are the drugs are available which are the cyclized. So that's why we have identified that cyclic peptide will definitely give you the good activity. And with respect to that, we have synthesized 10 molecules. A part of 10 molecules, these 4 molecules are very effective results saw, and it will give you the good antimicrobial activity. If you are comparing with the standard drug, it is more improved result compared to the standard drug. So it is also showing a very good antimicrobial activity. After that, we didn't stop over here. We want to compare the anti-cancer, antimicrobial activity of a small peptide molecule with respect to the decapeptide. Decapeptide, it means the 10 peptide bonds are available. So we go up to the decapeptide with the similar type of liquid phase, solid phase peptide synthesis technique. And we have identified that these are the molecules are also very effective anti-cancer activity. So we have studied with respect to the tamoxifen as a standard drug, where the 3A is showing a very good effective IC50 value with respect to the molecules. Just 1 minute. Okay. So with respect to that, what happened? We have published more than 10 papers. Its number is mentioned 10, but we have published more than 10 papers, and still publications are going on. We got the very good project from the government funding also, and with these small molecules we are getting the very good activity which is leading for the new research and new innovative in the field of the peptide molecules. So these are the list of the publications that we have already published with respect to that, and some of the publications are very good in the journals also. So the thing is that small peptides can be also leading with respect to the antimicrobial activity, anti-cancer activity, neurological disorder, and different type of this derma-based product also. So not going to the big molecules, like for example, if you see the semaglutide is very big molecule, big chains are available. Instead of going with respect to the big molecules, you can also synthesize the small peptides which will lead for the different type of activity, and it will go also target biologically effective. So these are the list of the students, those who are working under my supervision. So he already completed his PhD. So we started our peptide chemistry with the student. Then after this, he is also working in peptide synthesis. He is also working in peptide synthesis. Others are working in the heterocyclic synthesis and medicinal chemistry. And this is a person who is working with respect to the chromatographic analysis. And one more thing, I would like to inform you that we have certain type of instrument facility available at our MURC that I am leading this laboratory. So we have SAM, powder XRD, HPLC and other analytical tool. So if you have any query, you want to do analysis, you can directly come to us. We are ready to collaborate with you, and definitely we will analyze your molecules and the work that you are doing, and definitely it will be a collaborative part. So I would like to sincerely thank Marwar University to provide the all type of laboratory facility, and they are giving me chance to work in the peptide synthesis because I'm completely new in that. Previously, I'm working with the NMR and single crystal XRD. I switch analytical chemistry to organic synthesis, and the first task that I'm getting, that is the peptide chemistry. And you know that peptide chemistry is not an easy task. But identify that small molecules can be easily synthesized and developed in your laboratory. So I'm requesting all of the students, those who are sitting over, because you are the future of the pharma industry. If you are working in the peptide synthesis, definitely your future is bright. Because nowadays the thing is that pharma industries are introduced this particular project. So I would like to say very thank to Saurashtra University Department of Chemistry, Chirantan, Sanstha and the KCG for providing me the facility. So I think I completed. No, that's fine.
जडेजा जी, ये जो है ना, ये हमको कनेक्शन दिया, मैडम के साथ बात करो, सब कुछ हो जाएगा. So big thanks to you also. He's a part of this system. We give a big applause to him. He didn't hesitate. He immediately he sent the madam number. Thank you. Thank you so much. Marwar University will come.
Definitely, you're always open.
So next lecture is delivered from the Dr. Soumya De. Dr. Soumya De is a distinguished biophysicist and associate professor in Department of Bioscience and Biotechnology, Indian Institute of Technology, Kharagpur. And he has completed his doctoral studies from Cornell University, and he has also completed his postdoctoral research in British Columbia and Canadian Institute of Health Research. And Sir has renowned in his pioneer contribution to the biophysics, structural biology, protein engineering and NMR spectroscopy. And Sir has published more than 40 publications and also handling many research projects in her field. So I request to Sir. So, Sir, stage is yours now.
Okay. Thank you. So, first of all, I'm grateful to CRS for giving me this honor, and also a big thanks to Saurashtra University and all the organizers for putting together such a wonderful symposium. So I came here on 7th, and I'm here for the full time, and I enjoyed my time here. So okay, I'll quickly go through what I have been working for the past few years. So I'm going to talk about something that's a little different, and it is called intrinsically disordered protein. So when we talk about proteins, we think about structure function paradigm, right? So we think that for proteins to function, you need to have some structure. And if you can solve the structure, you can actually figure out what the function of that protein is. Now this whole paradigm got into question when these type of proteins were discovered, which are called intrinsically disordered proteins. These are proteins which do not have any structures, but still they actually have very important biological functions. And this is something that we are studying in our lab. So if you look at the current spectrum of protein structures, on one end, you have structured proteins like this, for example, enzymes, which have very unique folded structures, and based on that structure, they can catalyze reactions, or if you think of antibodies, they can bind to antigens and things like that. On the other end of the spectrum, we have disordered proteins like this. And if you look at the abundance of these proteins, in eukaryotes, these proteins are quite abundant, right? So almost 20% of proteins are intrinsically disordered, so that's a big number. So these are not that rare proteins. But if you think about proteins, they are all made up of 20 amino acids. So the amino acids are exactly the same. So what is different between a structured protein and a disordered protein? And it turns out that the composition of amino acids is slightly different. And this was nicely shown by Uversky, that if you plot the mean net charge of a protein sequence and its mean hydropathicity, you can see a clear distinction between unfolded proteins and folded proteins. So this is famously called the Uversky plot. And now, of course, there are many bioinformatics tools where you can just put in your protein sequence, and it will tell you whether this protein is going to be folded or it is intrinsically disordered. And now, in the past 2 decades, lot of biological functions have been discovered where intrinsically disordered proteins influence these biological functions. So if you are interested, you can go through this excellent review. I'm not going to go through all of that. What I will focus on is this particular part, and this is the major focus of my lab, that we look at particular type of proteins which are called transcription factors, and they have these huge disordered regions, and how these disordered regions influence the function of these transcription factors. So transcription factors are basically proteins which bind to very specific DNA sequences, and they can regulate the function of a downstream gene. So they can turn on the gene, which means that protein will be produced, or they can suppress that gene, right? So this control is very important, and if this control is gone, then all sorts of diseases come in, and one of the major diseases that happens because of misregulation of transcription is different types of cancer, right? And I will talk about one type of cancer, which is leukemia, that is blood cancer. The proteins that we study are Hox transcription factors. So there are 39 Hox transcription factors in our body, and these are very important proteins because they determine how the body of a vertebrate, bilateral vertebrate is designed. So where your head will be, where your hands will be, where your legs will be, that whole body plan is determined by these Hox transcription factors. If you switch the position of these Hox transcription factors, then, and it has been shown in Drosophila, that legs come out from its head, right? So this is a very unique type of transcription factor. But then once the body plan is set, then what happens to this transcription factor? Even in adults, they actually, so these are the proteins that we are working on. So even in adults, they are involved in the formation of different lineage of blood cells. So if you think about your blood, we think that it is red, right? So red is red blood cell, and the other is white blood cell. But this white blood cell is actually composed of 50 different types of blood cells, right? And they come from a particular type of cell, which is called the hematopoietic stem cell. So from this cell, all these different cell types come up, and that is called the different lineages of blood cell. And these transcription factors, the Hox transcription factors, they play a very important role in the formation of these different types of blood cells. And these blood cells are very important in your immune system. So when you get some sort of viral infection or bacterial infection, these are the cells which will fight for you. Okay. And if these transcription factors don't work properly, then of course all sorts of diseases can happen. So what I will do is I will quickly summarize the results that we have seen, that how these disordered proteins can affect the function. So typically Hox factors look like this. They are around 250 to 500 amino acids long. They have this small folded domain, which is around 50 to 60 amino acids long, and the rest of the protein is disordered. And it turns out that this disordered part is the one which bestows the specific function in that Hox protein. Okay. So one thing that we have seen is that these disordered regions have small segments, which we call hotspots, and these hotspots are important for interaction with other proteins. I will show you one example. So they can interact with other proteins. They can bring these proteins into the transcription machinery and decide whether the downstream gene will be transcribed or it will be repressed. We have seen something like this where this disordered region can bend back and interact with the folded domain, and it can inhibit its function. So this is something called autoinhibition. And then this autoinhibition is gone in the presence of these partner proteins. The third one that we have seen is that the disordered region can actually fold upon binding. So when the protein binds to DNA, the disordered region actually folds up, right? So these are all mechanisms by which the disordered region can influence the function of the transcription factor. Apart from that, this is also something, a new phenomenon that was discovered maybe 15, 20 years back, which is called phase separation of proteins. So disordered regions in proteins actually drive such phase separations. So we are studying this phase separation in one type of protein, and we suspect that it is also present in some of the Hox proteins. So to study these disordered regions, NMR spectroscopy is a very useful technique, because if something is disordered, then there is no point in solving its structure, right? But what we can do is we can look at its dynamics. And NMR spectroscopy can look at dynamics at this broad range of time scale. So we can look at fast time scale dynamics, we can look at slow time scale dynamics, and there are all these different experiments which can report in these different types of dynamics, right? So what we are doing is we are looking at this R1, R2 NOE, which is the fast time scale dynamics, because we are looking at something which is flexible and that can move around very fast. Okay, I'm going to sum up. So I'm not going to go through the details of NMR spectroscopy, but what essentially we have seen is that these disordered regions, they have rigid segments. So you can think of my hand. So this is a rigid segment, this is a rigid segment, and then it is joined by a flexible segment, right? So these disordered regions are something like that. You have rigid segments, some residues which are very rigid, and then there are flexible regions. And these rigid regions are the ones which interact with the partner proteins. So they actually show up as hotspots for interaction with partner proteins. For example, when we added this protein and this protein, we saw that the interaction is only happening in the disordered region, and we can monitor it by NMR spectroscopy, right? So this type of experiments you can do only by NMR spectroscopy, not by any other method. So then we also found autoinhibition in another Hox transcription factor. So if you just look at this, binding affinity is very tight, but if you look at the longer constructs, then the binding affinity goes up. And then by MD simulation, we figured out that there is this tryptophan in the disordered region which folds back and interacts. So if you mutate that tryptophan, you can get back that binding affinity, right? So if you take all of this information together, and you can actually make models like this, that okay, this is a transcription factor, this is the disordered region, this goes and inhibits its DNA binding, but when the partner protein is there, then the partner protein binds this tryptophan, so no autoinhibition, and together they can bind DNA. So this is how different types of transcription factors can come together, and they interact with each other through these disordered regions, and they can regulate the binding affinity to different promoter sites. Okay, so this is just a summary of what I have said so far. So there are a lot of collaborators. Again, I mean, this is just one project that I discussed. We also work on protein engineering and nanoparticles also. So we have a lot of collaborators in different institutes, and funding we get from these different agencies. And of course, most of this work are done by these students. Some of them have graduated, some of them are still in the lab. So what I presented today was done by Snigdha and Somendu. So these are the students who actually did most of this work, and I'm here to present. Thank you. Thank you for your attention.
He's our associate editor. I have to give a lot of respect.
Yes.
We are learning late, so without wasting time, I invite Dr. Priya Patel and Dr. Kushal Kapade for next session's chair.
So once again, I welcome you all on the Best Research Award presentation session. For this session, for our first presentation, we have with us Dr. Pooja Bhandari. She is an assistant professor in the Department of Chemistry at Saurashtra University, Rajkot. She completed her PhD in chemistry in 2025 and extensive teaching and research experience spanning academia and industry. Her research focused on metal organic framework, chromatographic technique, and natural product extraction. Prior to joining at Saurashtra University, she served as an assistant professor at Kadi Sarva Vidyalay and worked as a junior research fellow under a GSBTM funded project. Dr. Bhandari has published several research projects in international journals and actively contribute to interdisciplinary chemical research. So now I would like to invite Dr. Pooja Bhandari for her presentation. Ma'am, you have 5 minutes for your presentation.
Hello. Good afternoon, everyone. So my name is Dr. Pooja M. Bhandari. I have worked on the metal organic frameworks. My thesis title is Studies of Metal Organic Frameworks and Their Utility. Next slide, please. So the metal organic frameworks, we have already heard 2 awardees speaking about this topic. So metal organic frameworks are the porous materials. Next slide, please. And we also heard about the Nobel Prize of 2025. These three scientists have received Nobel Prize for the development of metal organic frameworks in 2025. Next, please. So how can we synthesize the metal organic frameworks? These are the different synthesis methods. For example, if I say 2, 3, so sol gel method, microwave assisted method, hydrothermal synthesis, sonochemical synthesis, electrochemical synthesis, etc. Depending on the synthesis method, we can change the morphology of the compounds and increase the porosity as well as their stability. Next, please. So if we talk about the applications, metal organic frameworks have a lot of applications, including the green applications for the environmental remediations. If I say something, for the highest recommended application is CO2 adsorption. CO2, we all know that it is responsible for the global warming. If I talk about wastewater remedies, then it can easily adsorb the colored materials or from the wastewater, for example, hazardous dyes. Next, please. So research motivations, from where I got the idea to work on the metal organic frameworks. So we have the lot of problems regarding environmental issues. For example, industrial wastewater contains hazardous textile dyes. So some of the people in the world do not get clean water to drink or for the use or in the daily use. Conventional absorbents suffer from low efficiency or poor reusability. So metal organic frameworks provide high porosity and tunable structures. As I said, depending on the synthesis method, we can tune their structures. Objective to work on this particular topic was develop a green bio-inspired MOFs for sustainable wastewater remediation. Next, please. Research highlights, we have synthesized metal organic frameworks using sonochemical synthesis specifically based on amino acid molecules. We have considerable best surface area received from those molecules, and we have also studied the xylenol orange, one of the highly intense dye. We have studied the removal of xylenol orange dye using our molecules, and our molecules removed within 2 hours of this these hazardous dyes. Potential for wastewater treatment and environmental remediation. Next, please. So if I talk about the research scheme, as I said, we have used amino acids, for example, glutamic acid, aspartic acid, etc. and we merged it with the different metal salts using sonochemical synthesis. We, as you can see the same images and dye adsorption applications. So research journey was developed zinc, copper and manganese based MOFs used amino acids as eco-friendly linkers, evaluated structure and functional performances. Next please. If I talk about my publications, first publication was in Journal of Molecular Structure, impact factor 4.7, and second publication is in the Wiley, Applied Organometallic Chemistry, impact factor 4.3. Thank you very much.
Thank you, Dr. Pooja, for completed on time. Now our next presenter, Ms. Nupur Nagar. Ms. Nupur Nagar is a research scholar in the Department of Bioscience and Bioengineering at IIT Roorkee. She earned her master degree in plant biotechnology from Terry University and is pursuing doctoral research focused on structural biology, molecular interaction, inflammation and protein ligand interaction. Her research has resulted in more than 25 scientific publications, including papers in Science, Science Advance, and other more reputed international journals. She is also a recipient of SERB International Travel Award, reflecting her excellence and growing international recognition in biomedical and molecular bioscience research. So I would like to invite Ms. Nupur Nagar for her presentation.
Can you just start it again? No, back it. Yeah, back. Thank you.
Hi, good afternoon, everyone. First of all, thank you to the CRS team and everybody for inviting me here and awarding me with the Best Thesis Award. So, today I'll give a brief gist about what my thesis was about, during my PhD. So my thesis title was Molecular Insights into Binding Interactions and Conformational Landscapes of Chemokine Protein. So mostly I worked on computational structural biology. So I'll start with a brief introduction, what chemokines are and what is the function. Can you yeah. So basically chemokines are small protein molecules which are inflammatory proteins, immune proteins, which interact with GPCRs and glycosaminoglycans. And the interaction has basically two specific characteristic feature. That is, they imply a specific functional role, and the interaction is because of interaction promiscuity between the chemokine and GPCR GAG interaction. So the chemokine, the specific functional role and interaction promiscuity are based on these characteristic features, which are mentioned here. So the whole rationale of the thesis was that if chemokines have promiscuous interaction, why do they have still specific functional role? So to understand this, we try to answer two things, like why chemokine interactions are promiscuous and still specific, and the second question that we tried to answer was how dynamic or plasticity, conformational plasticity guides the chemokine ligand or chemokine GAG interaction. So understanding this actually helps to understand the structural aspect of chemokine interactions, which is important to provide a structural insights into targeted development of drugs and therapeutics. And the study was, the study targets three main aspects of chemokine interaction, which is its interaction with GPCR, its interaction with glycosaminoglycan mimetics, and the third is a very novel topic with perspective to chemokines. So we have tried to analyze how chemokines can interact with some xenobiotics which can be present within the bloodstream. So moving forward, the first topic that I would like to discuss is the role of evolution and interaction promiscuity in defining chemokine GPCR interactions. So the whole study was done with started with evolutionary analysis and then MD analysis. So for this we picked a subset of chemokine family, which is CC chemokines, and we studied the molecular evolution of the whole family and saw that the changes are happening within the N-terminal region of the protein, which is actually involved in receptor interactions, because of which there is a possibility that the chemokines can actually interact differently with the same receptor. So then we performed MD simulations where we saw that the structural heterogeneity or the conformational dynamics of all four proteins, which are very close to each other, are very different. And then we performed structural modeling using AlphaFold 3 and performed the binding energetic analysis and interaction analysis, which indicated that even though the proteins have a similar binding affinity with the receptor molecule, their interaction patterns are very different. So we wanted to answer how and why is this happening. So for this we ran MD simulation. So we ran long range microsecond state MD simulation. So we ran around 5 microsecond simulations, and we saw that in the upper state the N terminal actually collapsed in the during the MD simulation, while for the complexes in CCR2 and CCL2 structure, there were helical, the flexibility in the helical bundle, the transmembrane bundle was higher compared to CCR2 and CCL3 complexes. Then we performed Markov state modeling on this to understand what actually is happening within the transmembrane helix, due to which the structural dynamic features, the dynamic conformations are changing. And we saw that when CCL2 is interacting with CCR2, what it is doing is, it is actually shifting the transmembrane helix conformation from one position to another, while for CCL2, CCL13, the structure was mostly rigid. So this is even though the binding energetics were almost similar. So the whole conclusion of the story was that the interaction with different kinds of chemokine for CCR2 actually influences the minute structural changes, because of which the helical dynamics of transmembrane changes, and the activation process of the whole chemokine receptor interaction can change and influence the immunological pathway that is activated by the chemokine mediated system. The next topic that I worked on is to answer how conformational plasticity can guide chemokine GAG mimetic interactions. So basically, conformational plasticity means that the protein can actually modulate itself so that the ligand can go and fit into the binding pocket. So we wanted to understand. Okay, sorry. So we wanted to understand what will happen if a mimetic can actually interact. So here we have we had a combination, we involved a combination of virtual screening and experimental setups. So here we identified a molecule called suramine, and we performed ITC experiments to understand the binding energetics and affinity of the protein. Then we performed MD simulation and NMR, in which NMR the NMR actually from NMR we got to know that the interaction actually involves intermediate exchange process, which indicates that the structural heterogeneity is present because of interaction of suramine with the chemokine molecule. So this paper has been already published, and we understood that the plasticity, because of the conformational plasticity, the conformation actually changes of the protein, because of which the ligand goes and sits into the pocket, and it stabilizes the chemokine ligand interaction. The last topic is is a very interesting and new topic. So what we wanted to understand is whether PVC nanoplastic can bind to chemokines. So nanoplastics have we know that nanoplastics can go into our body and then cause immunological disorders and inflammatory conditions. So we wanted to understand whether chemokines can interact with nanoplastic or not. So first we identified with MD simulation the binding pocket of PVC, like polyvinyl chloride, and then we identified whether the structural changes are happening within the protein because of PVC or not. Just 1 minute. Yeah. So PVC or not. So we performed the simulation and we saw that structural changes are actually happening. Then we we modeled the whole PVC nanoplastic structure using simulated annealing and coarse grain simulation. So here are some movies So we actually performed simulation, coarse grain simulations, where we saw that the protein goes on and binds to the PVC nanoplastic structure, and it forms a protein corona. So this is the whole conclusion of the thesis, and I would like to acknowledge IIT Roorkee Professor Krishna Mohan Paulri for giving me a platform to do this work, and all my lab members, and of course CRS team to present my thesis work here.
Next we have Mr. Karan Savalia, a young entrepreneur. He owns 3 companies, Savitur, Prerna and T1 Life Science, having WHO and GMP facilities. He is the first having Spectrochem authorized dealership with his own depot. Apart from his business orientation, he is also running a free career placement seva to serve the society. I pleased to welcome Mr. Karan Savalia.
Respected professor, researchers and dear students, I am Karan Savalia, Director of Savitur Life Science and T1 Life Sciences, both based right here in Rajkot. In the next few minutes, I will show you who we are and 2 things that matter directly to you. Laboratory chemicals delivered in 24 hours and completely free career support initiative for scholars. Next, our group work is one supply chain. T1 Life Sciences is our manufacturing arm, WHO, GMP and ISO certified API plant at Padadri, Rajkot with in-house R&D. Savitur Life Sciences is a trading CDMO and lab chemical arm in the first authorized Spectrochem dealer in Saurashtra region. So from manufacturing an API to supplying the bottle on your lab bench, everything is under one roof. Next. A quick look at T1. Our portfolio covers therapy areas from cardiovascular to central nervous system drugs, rosuvastatin calcium, nintedanib acylate, deferasirox, idaravan, cariprazine, and more. Every batch is released with a full CO and technical package. If your institute or company needs an API, an intermediate or custom synthesis, we do it here in Saurashtra. Next. I especially want to introduce our scientific advisor and mentor, Dr. Rajendra Chawda sir. He carries more than 24 years of experience in the Indian pharmaceutical industry, having played vital roles in leading organizations across manufacturing quality and plant operation. His expertise guides Steven's APA process and Savitur's CDMO work, and most importantly, for the students in this hall, sir has personal contacts with the pharma companies all over India. Remember this point, I will come back to it next. Now something very practical for every lab here. Savitur Life Science is the first authorized spectrochem dealer in the Saurashtra region, and we maintain a spectrochem depot right here in Rajkot. The full chem index range AR, LR, HPLC grade solvents, reagents, indicators, and fine chemicals. Every product with its COA. Here is the difference in one picture. The old way, material dispatch from Vadodara took 4 to 5 days. The Savitur way from our Rajkot depot is 24-hour delivery across Saurashtra. Order today, start your experiment tomorrow, and because we are direct authorized dealer with local stock, we offer the most competitive spectrochem pricing in the region. Bring us any quotation, we will match the market and beat it the waiting time. This part is specially for student and research scholars through Rajendra sir's network. If you are interested in the pharma career, production, QC, QA, R&D, analytical development, regulatory affairs, stores, or marketing, we will connect you with real openings and relocate you anywhere in India, completely free, no fees, no charges. This is not a business for us, it's our seva to young scientists, and all you have to do is fill one form. Next. And everything comes together in this one QR code. It is also on the table card at our stall. This form has 2 simple sections. Section 1, your spectrochem chemical requirements. We reply with our best price in 24-hour delivery. Section 2, with your career details. Rajendra sir's team matches you with company across India, relocation free. It takes less than 2 minutes to fill it. Please scan it before you leave. Next. Thank you very much for the time. Please visit our stall and pick up the spectrochem price list, scan the QR and talk to us whether it's chemical unit tomorrow morning or a career opportunity anywhere in India. Savitur and Tivan are here in Rajkot for you. Dhanyavad.
event to please escort all the dignitaries to the dais.
I heartily welcome all the dignitaries once again to the valedictory function. We will now proceed to the ceremony. Before to that, we would like to get a few feedbacks from the delegates regarding this international symposium.
Any delegates wants to share their views about this conference, so we are requesting you to please share your feedback about the conference.
We don't have time for us to leave. One person, quickly. We give some cash prize. One. Right.
Please, sir.
Good afternoon, respected dignitaries on the dais, off the dais, dear colleagues and friends. I'm first of all thankful to Saurashtra University for their hospitality and thankful to CRS for recognizing our research work, and we are not, especially I will not go with application for any awards or something. So identifying our work in spite of we have not gone with the application is a major award. I thank CRS for its recognition. And the man behind this is Dr. Professor Channa Basappa V. Elamagad, that is actually the name is. So I thank very much to Professor C.V. Elamagad sir for this. And apart from this, I should be thankful to Saurashtra University because I could see the persons from the university. They are very humble, including Vice Chancellor. So we had conducted many conferences like this, but our Vice Chancellors are free. They will come, they will just visit and run away. But here, sir is with us in all 3 days, and he is a leader, a real leader behind the program. I must be thankful to him. I am thankful to the coordinator, Ranjana Madam, as well as her students, mainly the research students as well as MSc students. So they are so humble, and they know our actual travel time period, where we are staying, what we require. So they used to ask everything. So I am very much thankful to all of you. Thank you once again. Jai Hind.
Thank you so much, sir, for your valuable feedbacks. It means a lot to us. We'll surely try to incorporate all this. Now I request our Honorable Registrar, sir, to please come forward and address this gathering.
Namaskar. I'm not taking much of time. Respected Vice Chancellor sir, respected Padma Shri Shivram sir. I'm first of all thank you to CRS for giving opportunity to organize this wonderful conference and give us opportunity. And to give us opportunity to felicitate so many research scholars and senior most scientists in the Saurashtra University. And I am also thankful to our Honorable Vice Chancellor for every support to organize this conference. He is always a backbone of all the activity, whether it is co-curricular activity or research activity or any kind of academic activity. So without his support, the conference will not succeed. So I'm very much thankful to Honorable Vice Chancellor sir. And all credit goes to CRS as well as the team chemistry department, Professor Boya, Professor Ranjan Ben, Professor M.K. Shah, all the research scholars for their tireless and painstaking efforts. I am very much thankful to the entire chemistry department as well as most energetic Professor CV. It is very difficult to pronounce his surname, so Professor CV and Professor Braj Gopal Das. Thank you, entire CRS team. Thank you. Jai Hind.
Thank you so much, sir. Now I request our Honorable Vice Chancellor, sir, Professor Dr. Utpal Joshi, to please come forward and address this gathering.
Namaskar. So finally there is a sigh of relief on one hand with a very positive and happy note, and in the concluding session, if the auditorium is full, your event is grand success. And really I feel our confidence and enthusiasm boosts like anything, because this is the second event in the less than 1 year time that we are organizing in this university, one with the physics department and nanoscience department together, international conference. That was also a series of conference. So we bid for it and we won it, and it was a grand show. So what is important for any event to be successful is not the success story of one or two persons. We are here just to help you in some way. The actual work is from the team, and I from bottom of my heart congratulate Department of Chemistry, Saurashtra University, Bhoya sir, Ranjan Ben, and the entire teams, and particularly volunteers, Pooja and everybody. They have done a huge job. This is not easy. Starting from, and then initially even in my inaugural remarks I mentioned that the season that was chosen, July first part, it is just like a rainy season, but God has blessed us with that. We were prepared actually for that, and I was a bit concerned about that, how to commute, the people from here to hotel. So everything went well. Really feeling it's a matter of pride, and not only the students, our young faculty from all the science departments have gone to airport. Even head of the department and most senior faculty like Ramesh Kothari ji, they all went to airport and picking up the dignitaries in any time their own car. So this is something what we say, it's really a matter of pride for me personally that I have a team of people who don't see the time, don't see this, whether it is concerned to that subject or not, but they are always eager to help, happy to help. And that is the reason why, our confidence level goes up as an administrator that, okay, we will do it. So that's a very nice spirit. I also mentioned Rekha ji here, Rekha Jadeja, who is with a very short notice of time that yesterday's evening, you know, all our girls from hostels, they put up the show. It was magnificent. We instructed that it should be limited to 45 minutes, but that 45 minutes was so enriching and you know, so pleasing that everybody must have enjoyed, those who are there. Okay, so one group of Kannada, 11 people have gone to Somnath today, right, the Bangaloreans, and the other group I think also has gone and come back. I think Sangeeta was talking to me yesterday. So there are many places to see around. Gujarat is blessed with 1,600 kilometers of coastline, and beautiful beaches are there. Next time when you make a point, just stay back here for 2 days, you will get to know so many other things. So finally, CRS, we are here to help you out and try to, you know, fix up the dates, whichever the convenient to you, suitable to you, at whichever the place. All our volunteers, energetic, you know, faculty, young faculty, they are also will be of great asset to any of the work that you do. Those who are coming from the institutes, IITs and ISERs, and we have a very nice series of lectures. They are so enriching to me, and personally I feel that I should sit. I mean, I was feeling guilty sitting there and signing the papers, but somehow or the other I thought that I should attend each and every lectures, but it was not possible somehow. And this I learned from very small incident I would like to share with Professor Sriram. When I was young, around you know, that time, I visited the Indian Academy of Science annual meetings because I was associate with that. So in one of the meetings in Punjab University, Chandigarh, Professor Ken Pathak at that time was a very well-known theoretician in IIT Bombay. Then he was a vice chancellor there. So what he instructed to their office staff that you can just put the files here in the one of my, you know, adjacent seat. I will sign it here only, but I will not miss a class in that, any of the lectures. And that is what the spirit, and really it was so admiring that, yeah, of course, so many things are happening around us. We have to be punctual in time, but at the same time, this is also very important to update ourselves. Thank you so much for being here in Rajkot and giving us the opportunity. Any of the inconveniences, I personally apologize for that. Thank you.
Thank you so much, sir. Gearing up, we would like to hear it again from our chief guest, Dr. Swaminathan, sir. Sir, kindly come forward. As you know, it is always a pleasure to hear from you, and also a sheer joy to have you. Please, sir.
You know, you should never give me the stage, okay? Because you can't stop me from talking then. All right? So never do that. Anyway, thank you for this opportunity to be here. I think I would like to acknowledge a deepest appreciation to the Vice Chancellor of the Saurashtra University that he could offer this location as the host for this meeting. I like to, of course, compliment CRS, Professor Elamagad and Professor Das for their leadership to organize this event and to bring people to Rajkot. You know, normally otherwise many of us wouldn't care to come here, but they were so persuasive. Initially I thought I may skip, but they were so persuasive that I still could manage to come here and at least spend, you know, less than 24 hours, but at least I could spend some time in this campus. I think you are doing a very noble job trying to connect the chemistry professionals across the country, recognize them for their whatever excellent work they are doing, and many of them I know that they are doing this work under extremely trying circumstances where the facilities are not necessarily the best, but they're all trying they're the best to do good science, and I saw some glimpses of it this morning when I was hearing some of the talk from this region and this university particularly. So I like to compliment all of you because I believe that doing good science is the art of the possible. You know, you can ask for any number of facilities. That's a different matter. If you get it, you are lucky. If you don't get it, now it's not that you can sit idle. I think if you have the brain, if you have a couple of hands, we can do miracles. Okay, we don't need anything more. Okay, it's a question of the will to do it, the desire to do it, the passion to do it. That's all you require. The rest of it will follow. Don't worry about it. Don't wait for something to happen before you start. You start and everything will happen. So that's my advice. And I like to, I'm particularly happy to the organizers of CRS that they brought such activity to the university, because I see these young students here. And I have great faith in the future of India, because I believe that these young people, I go to many people, I talk to many students, I talk to, interact with them. I see spark in their eyes. I see the desire to do something, And I hope that we can provide them as people who are in this country, we can provide them. We can't provide them everything. As I told you, we are a resource-starved country, but at least we can provide them the moral encouragement for them to do, okay? And I think that moral support, that we are with you, you can do it, and we will help you as much as we can, is all that I think we need to provide. And I think this young people in this audience, and I think there are many people, they come and talk to me, they are doing their PhD, they are doing their MSc. I think these are the greatest resource that this country has. So let's nurture them, let's support them, and I'm glad that your organization is bringing the best of science in India to this audience, who otherwise may not necessarily be interacting with them in their period of stay here. So I think you are bringing the best of scientists in this country and asking them to talk to this audience. I think they will be inspired in the process. So good luck to you. May I wish you the very best as you take this effort to greater and greater heights. Thank you very much.
Thank you very much, sir. We forever will be grateful for your gracing to our audience. Thank you. So moving ahead, we'll be having the most awaited part of any such gatherings, that is the Best Presentation Awards. Yes, Best Poster Presentation Awards. So I request all the names that we take, they are the winners, to kindly come as quick as possible and collect your awards.
And I request all the dignitaries to please kindly present this award for the best poster.
So we will be having 10 best poster presentation awards, right? So the first one to have it is Yash Kumar R. Soratia. We're having 10 best posters, so there is nobody the first, the second, right? 10 best awards, yes. Yeah. The second one is Animesh Pal, Mihir Bajak, Kinjal Parmar, Dr. Dharmesh Kataria, Kausha Bhatt, Gohil Payal, Hetal Aghara, Gajera Rohit, and Kavita Ba Jala. I hope everybody is present here. I request the audience to please give a huge round of applause for all the awardees. Yes, Dr. Dharmesh Kataria. Kausha Bhatt. Gohil Payal. Next we have is Hetal Agara. Kavita Bajala.
Thank you, dignitaries. Please take your seats. I request President CRS, Professor Dr. Bagh sir, to please come forward and address this gathering.
Good morning, everyone. Good afternoon. Okay, good afternoon. And I don't know whether I can tell Shubh Shohar also now. Can we tell? We can tell Shubh Shohar. Kem Cho. Kem Cho. Kem Cho. Good. Guest of honor and also the chief patron of this symposium, Honorable Vice Chancellor of Saurashtra University, Professor Utpal S. Joshi. Guest of honor, Padma Shri Dr. Swaminathan Sibram. Guest of honor, Registrar of Saurashtra University, Dr. Ajay Singh Jadeja. Honorable Vice Chancellors, Deans, Directors, and heads of various departments and centers, other administrative officers, head of the Department of Chemistry, and also convener of this symposium, RASAYAN-23, Professor Bhoya, organizing secretary of the symposium, Professor Ranjan Sikhund, secretary of Chirantan Rasayan Sanstha, Professor C.V. Yalamagad, all the CRS award recipients, representatives from industries, and most importantly, the heartbeat of this conference, scientists, faculty members, postdocs, research scholars, students, staff members, media persons, and ladies and gentlemen. It gives me an immense pleasure to say a few words during the valedictory session of the 3-day international symposium entitled Science Beyond Boundary, Invention, Discovery, Innovation and Society, RASAYAN-23, organized jointly by the Saurashtra University, Rajkot, Gujarat, and the Chirantan Rasayan Sanstha, in association with the prestigious societies of India like Society of Materials Chemistry India, Indian Council of Chemists, and Electrochemical Society of India. I am sure all of you will agree with me that what a fantastic international symposium we had in terms of the extremely high standards of the scientific deliberations and extraordinary scientific exchanges, networking, and also opening future possibilities. The blessings and encouragements received from the senior awardees like Professor Kakodkar, Dr. Swaminathan Sivaram, Dr. Harish C. Varsilia, and all others will motivate us not only to carry out more and more creative work, but also to organize such events in the future. Saurashtra University is celebrating its glorious 60th year anniversary, and let us congratulate for this to them. CRS is a much, much younger society, established in the year 2016, and celebrating its 10th year anniversary. So we congratulate them and the council members also for this, for the glorious 10th year. We are indeed grateful to Saurashtra University, its Honorable Vice Chancellor Professor Utpal S. Joshi, and the entire team of Saurashtra University for hosting this memorable event, RASAYAN-23. Everyone will remember your fantastic hospitality, the delicious food, and above all, the warmness in the interactions throughout. This is the biggest Rasayan series of symposia that we ever had in terms of the number of awardees going as high as 75 plus 10, so 85. 3 speakers were from abroad who could not arrive here due to some prior commitments, but we could listen to their virtual presentations, including the presentation of the Nobel laureate, Dr. Venki Ramakrishnan. Otherwise, most of the speakers arrived here and presented their award lectures, by which all of us were enriched, not only with their inventions, but also with their foresightedness. We are indeed grateful to all the awardees. One of the most interesting events was the introduction of Best PhD Thesis Awards, where the future leaders of science and technology were recognized for the first time. And additionally, there were outstanding quality 74 poster presentations, out of which 10 posters have just been awarded with the Best Poster Awards. We acknowledge all the poster presenters and congratulate the Best Poster awardees for their excellent poster presentations. Moreover, what a fantastic cultural program we enjoyed last evening, and that also performed by the students of this university. You could train them, and then you could provide a platform to perform. This is how it should be. In fact, now we are under NEP 2020. In NEP 2020, encouragement is made for such activities by forming various clubs within the academic institutions. We at the Vidyasagar University also have various clubs, including music club, cine club, drama club, dance club, and Patanjali Yoga Club, etc. I happen to be the chairman of the Patanjali Yoga Club. All the stakeholders of the university participated in the International Yoga Day celebration, which was held recently on June 21st, 2026, in a massive way. It is true that CRS council members worked very hard to get the world-class scientists on the same platform. But it is the host institute, the Saurashtra University, Rajkot, Gujarat, India, that brought our dreams into reality. What a fantastic coordination we have seen among the faculty members, research scholars, staff members, and the students during the last 3 days. Let us give a big hand to all the Saurashtra University organizers. Moreover, we have seen a fantastic synergy not only within Saurashtra University, not only within CRS, but also between Saurashtra University and CRS. Whenever we find a scope, we will try to have some of our programs and activities here too. Swami Vivekananda statue is there at the Vidyasagar University, Meenapur, where I come from. But when I found the image of the statue of Swami Vivekananda inside the RASAYAN-23 circular, that gave me an humor and immense pleasure, who spread the message, Jibe Prem Kore Jai Jon, Sei Jon, Seviche Ishwar. CRS and Saurashtra University also are spreading the same message. Loving all is a service to God, trying to reach all for a better society and mankind. There also we find the fantastic harmony in our goals and activities. Any program has got an end. We are also almost at the end of the 3-day International Symposium RASAYAN-23. But the take-home message, the sweet memory, the motivation, the inspirations, the blessings will remain with us forever. CRS will continue organizing such events, and we look forward to meeting you again in future events. Keep on performing the best. We will be there to encourage and recognize your talents. Thank you very much again. Namaste. खूब खूब आभार, धन्यवाद, जय हिंद, वंदे मातरम.
Thank you so much, sir, for a brief report about this conference, university, and CRS. Now, I would like to request the most enthusiastic person behind the international conference, that is Professor Dr. C.V. Yellamgad, sir. Please come forward.
Kemcho. Honorable Chief Guest of the event, Professor Swaminathan Sivaram, respected Vice Chancellor, my friend, very close friend. It's because of him it has happened. Utpal Joshi ji, respected Registrar Sir, Boya Sir, Kund Madam, and most importantly, my dear volunteers and students. Well, as usual, anything that begins, it should end. But end should be, takeoff is not a big deal. Landing is very important. We are landing slowly. It's a very, very smooth landing, indeed. For that, you have to give a big applause to all this, volunteers. Big round of applause to all the Indians. It's such a smooth one. Smooth landing, no jerk, nothing. We landed very smoothly. Took off well, landed very smoothly. And most importantly, the efforts you have put, as I said yesterday, I was studying in the, this cultural program. Sir, trust me, even night 4 o'clock, they pick my call, including madam. That is the commitment. I didn't see such commitments. Wherever I have seen, I think it's one of the best conferences we ever had, sir. Best conferences. That I'm very proud of all of you. And it's my present duty to sincerely thank all my, fellow scientists, my friends, colleagues, in particular, Professor Venki Ramakrishnan, who was, wrote a message, he corrected. Wherever we are doing wrong, he corrected. He keep on sending the mails. So that is the kind of commitment that Professor Venki Ramakrishnan showed to our organization. He said he will come and honor, he will participate in one of the events, he said. Secondly, we had a wonderful talk by Professor, all of you heard. It was very fantastic talk. He talked about thorium. He started 2047, what could be the thorium to the India, Professor Kakolkar spoke so well. And then we had Ettifield, Bosch from Germany and UK respectively, and fantastic talks from various, big organizations, popular organizations such as IITs, ISHRs, NITs, many places, including CENS, Center for Nano and Soft Matter Sciences, and many places. On behalf of you, on behalf of all of you, I would like to profoundly thank all the awardees for their wonderful presentations. Thank you very much. And it is my present duty to call all the volunteers on the dais. All the volunteers. Please come up. Don't shy. All the volunteers. Quickly. You have been quick. You have worked on second scale, but now it is picosecond scale. Please come forward. Yeah, we have to stand up, giving a bit. I request Professor Swaminathan Sivaram sir to bless them all. Bless them all. Hall is empty. You can kneel down. Some of you can kneel down, please. Quickly, sir, we have to move. I'll miss my flight otherwise. quickly. And the concerned faculty members can also join. आइए मैडम, जल्दी से आइए. When I go home, I'll be, missing sweet food, sweet people. Okay. May I request all of you to raise and give a big applause? Please raise. Please raise. Stand up. Stand up, please. अरे कितना क्या सोच रहे हो भाई? देता रहो. देने का ही है. एक दिन जाने का भी है. देता रहो. और एक बार. Thank you very much. Yeah. It is my pleasant duty. Please disperse quickly. Yeah, national anthem is there. Yeah. National anthem is ready. Huh? Yeah. Yeah, madam, I will tell. No, after me, she will tell, and then what next? Sorry. Yeah. Well, it is my pleasant duty to announce that there were 9 proposals to host next symposium. 9 proposals. So we had to, stick to one because KIT said they are going to sponsor 1 or 2 Nobel laureates physically, and they are ready to sponsor first-class ticket and all the kind of facilities they would like to give. 2 first-class tickets are with us now, and they are ready to host between the January 20 to 22. And I must thank on behalf of CRS, and please join me in thanking, giving a big applause to KIT. Thank you very much. Thank you. Bye. All the best to you.
Thank you, sir. As Dr. Stuti very rightly said that the most enthusiastic person, but I would like to add that the most down to earth and the most jolly person is a cherry on the top. So yeah, thank you so much, sir, for gracing us with everything. So now moving towards the very last speech, I would like to request Dr. Bhoya sir to kindly come and deliver a vote of thanks.
Distinguished dignitaries on the dais, eminent speakers, esteemed delegates, faculty members, research scholars, and my dear students. A very good afternoon to all. It is my privilege to propose the vote of thanks on behalf of the organizing committee of the International Symposium RASAYAN-23 on Science Beyond Boundary, Invention, Discovery, Innovation, and Society. As we come to the close of this memorable 3-day scientific gathering, I take this opportunity to express our sincere gratitude to everyone whose support, guidance, and dedication made this symposium a great success. I express my heartfelt gratitude to our esteemed chief guest, Padma Shri Dr. Swaminathan Shivram sir, for his special presence in this symposium. Among his busy schedules, sir has given his full days dedicated to this hug event that cannot be expressed in words only. Thank you so much, sir. I extend my heartfelt gratitude to our guest of honor, Honorable Vice Chancellor Dr. Utpal Joshi, sir, for his constant leadership and for sharing valuable thoughts that have inspired all of us. Your presence has truly enhanced the significance of the symposium. Without his continuous guidance, we might not be able to organize such a hug event. Thank you, sir. I also express my sincere thanks to Dr. A.K. Jadeja, sir, Registrar, Saurashtra University, Rajkot, for his continuous support throughout the planning and arrangement of this event. Your encouragement and support are a constant source of motivation for us and could make this event successfully. I would like to express my deep gratitude to the Chirantan Rasayan Shastra, Dr. C.V. Yelamagad, Secretary CRS, and Dr. Braj Gopal Bagh, President CRS, for trusting us and giving us this opportunity to host their large symposium. Your constant faith in our entire team has made us greatly honored and highly inspired. Thank you so much, sir. I would like to thank all the plenary speaker, session chair and co-chairs, delegates, faculty members, scientists, researchers, industrial representatives and students who travel from different institutes and regions to participate in RASAYAN-23. I sincerely acknowledge the generous support of sponsor and collaboration recognition. Your encouragement and contribution play an important role in making this international symposium possible. I would also like to acknowledge the tireless effort of the organizing committee, faculty member, research scholars, students, volunteers, office staff, technical staff, housekeeping personnel. A special thanks to media and publicity team, registration committee, hospitality committee, transportation team, accommodation team, technical support staff, photographers, and every who contribute in a countless way to the success of this event. Finally, I thank every participant for making RASAYAN-23 a vibrant platform for scientific learning, collaboration, and innovation. I once again express my sincere gratitude to each and every one of you for your valuable presence, support, and contribution. We wish you all a safe journey home and look forward to welcoming you again in our future science event. Thank you very much.
So with this, we came to a beautiful end to a beautiful gathering. I request all of you to kindly stand up for the national anthem.
पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता